Okay, hello. It is 10 a.m. today, and I need to go grab myself a coffee, and then we're gonna start on. We're gonna continue with the Prime Git video. My goal is to finish all of them by today. It's like 2 hours left. Probably gonna spend around 3 to 4 hours in total. We'll see. Right, I'm gonna show you something. I'm adding like a projector here. First of all, to improve my aesthetic, and then open some lo-fi song. That seems like a good idea. Do some like lo-fi background because I think it's like aesthetically pleasing, but then I'm gonna mute it. Okay, let's go back to the Prime video.
Yeehaw, force push, no. Work on a branch, feature branch, then open a pull request for review. That's how I do it. It just makes sense, right? So if you ever want to commit to open source, you obviously do the fork. You need to create a pull request. You need to do all that stuff, right? Git ignore is really important because obviously node modules, if you don't know about them, they're horrible. So you need to git add commit some message here, git push origin. Problems will arise. Git ignore file just simply allows you to say, here's a specific file or a class of files to ignore. You can also go with the inverse, which is you can ignore every file and then just add the files you want to have. It's kind of like a fun way to do stuff. If you've never done that kind of stuff, right? And so you can have, is this the first or second? This is the first part. So we're gonna create a node of modules, or we're gonna create a git ignore file that has node modules in it. Right, so if I go like this, vim git ignore. Oopsies, I already have vim open here. Whoopsies, we don't want to do that. I want a git ignore and go node mod.
Wait, you do git ignore.
Modules. Modules. By doing this, if I go like this, make dir foo, and then I go back to here. Let's see, and I go back in here, and I go in here and go like this, bar.empty, save that, and then I go one more and go node modules, and I go in here and add foo.md, right? Bam. If I go git status, you'll notice something. Foo hasn't been added yet, right? So it doesn't have any idea what's underneath. So when I go git add everything and do this, you'll notice that it only adds foo bar. It does not add node modules, and that's very important. And that's because this matched anything. It's just a match. So you gotta be careful. Careful. Include bid and build, you coward. No. Another cool thing about Git, I'm not sure if I talk about this. Here, I'm gonna go in here and I'm gonna erase that, right? I'm gonna erase that, git add this, git status. You'll now notice node modules is now added, right? Awesome. So that means, here's an interesting thing I can do. I can go in here and go git ignore. You can do,
okay,
let's see, let's go bar.
Anything
with the word bar in it. Git status. Now you'll notice we have this. And it didn't really quite do it. I believe I had to go MD exact match. Can I exact match it? Git add this, git status. I think because I already added it, it causes a weirdness. Git restore, staged, foo, bar.md, git status. There we go. It's gone, right? It doesn't exist. It's already been staged, so I had to unstage it. There we go. So if I erase this and go back here, git status, you'll notice that it's now able to be added back. So you can actually do inner directory git ignoring, which is pretty nice. I'm a big fan of that. If you want to do it. You don't have to do it, but it's cool. It's cool to know that it's possible. And one last thing that you can do as well is there's a file called what's it called? Git info exclude. You can see it right here. There's the path. Things that are ignored in here are ignored for your local repo. they're not ignored for everybody. And so this is a really cool little file right here if you don't know about it. I'm not sure if I talk about it, but you should. Like, say you, like, for me, one thing I always do is I go like this. I always have like an out file that I always have. So instead of adding it to my git ignore, I can just add it to my excludes. And by adding it to my excludes, when I go, when I run some sort of program, echo foo, and pipe it to my out file, when I go git status, my out file just doesn't show up. But nobody else has to know about my outs ignore. I like keeping all the ignores in one place. It doesn't make sense if you're working on a team, right? When you're working on a team, I have a bunch of stupid files that I create regularly, out2, and so I don't want to have out files inside the git ignore. So I put it inside the git excludes list, which is kind of like that special one. There's also a home git ignore. I didn't know about the home git ignore. Is this like one? Is this a global project ignore? See, I mean, Git has a lot of features, so I didn't know that. This is the same as a global level git ignore of your work. Oh, cool. All right, perfect. All right, so here we go. Assignment: create 2 files in your repo. Secure passwords.txt and create a seer. Let's see. First, create this thing. All right, and create that. All right, we're gonna do that, and then guilty pleasures.
Okay. I guess we could just go straight to here and then that git ignore. Okay. Then where's the assignment? Am I jumping too fast? Yes, I am. So I will go make their sick. We go cd secure. Yeah, and mvim password .txt, copy that, right click, create a file called guilty pleasure ID in the repo root. Okay, so cd new item. Nvim guilty pleasure touch. I actually have .git ignore. Commit your changes with the message and make sure that the git ignore file is included in the commit. Do not commit the secure password. The security or guilty, they should stay on track because they are ignored.
All right, perfect. Git check out main. I assume we're supposed to be on the main branch. Are we on the main branch? Yeah. Git status. RM, RF, foo. Let's get rid of all this. Git status. All right, git add this. Git status. There we go. Oopsies. What is it called? Webflix. There we go. I'm gonna get rid of that thing. Git ignore and go in here. Oh, that's not what we wanted in there. We wanted it in secure. And then what do you say? Passwords. .text or some crap like that. Is that what he wanted? Password.txt, yeah, and then one called guilty pleasures. All right. Guilty pleasures. .md. Boom. The notebook. Let's go. Guilty AF. Finally create a git ignore with both ensure both of those files are ignored. Ignore the entire secure directory, and then all right, perfect. Secure, and then guilty pleasures. All right, and then let's see, with the message starting with M. All right, git come.
Mango.
We gotta do a little M message. Git ignore my notebook pleasures. Okay, you don't know. You just don't even know how good the notebook is. All right. There we go. Nested git ignores. Oh, I actually already went through this. We actually talked about this exact thing, didn't we? Oh my goodness, we already did this. All right, which is ignored. All right, hold on. What are we doing here? Here's the let's see. Here's the contents. All right, we have these contents.
So only dev will be ignored, and main.py will be ignored. So it's only these two, right? I mean, test the py have nothing to do with it. This they will be. So main.py.
Here's the contents, which is this: source assets git ignore, which is going to be only.
Wait, here's the content of the git ignore.
Devs and main.py, and this one's going to be bin activate. So that one's going to be this one. Only devs and main.py, and this one's going to be bin activate. So that one's going to be this one right here. And this one's going to be only dev, and what's the other one? Main.py and main.py. Okay. Here's the contents. Wait, hold on. What's the question? Which is ignored? They're all ignored. Aren't they all ignored? Aren't they all ignored? Does not necessarily have to be at the root. It's fairly common to have this one. Am I misreading things? I mean, this one will be ignored. Yeah. This one should be ignored. And this one should be ignored. Okay. Oh, yeah, of course not. I'm so stupid. Okay, sorry, I'm so stupid. This one's main py, which does not exist at this level. Okay. I wrote this. I actually wrote this. This one won't be, and then the root one has bin activate, which this one should be ignored as well, right?
No, I only ignore the activate, right? It's the root.
Shouldn't that one be ignored just equally? Whatever. There we go. Only devs. I want a main cupcake. You can't have one. Wrong. What am I missing there? Sell boozled? Yeah. It's not one of the options. Oh, let's see. Activate is a shell script, not a folder. Venv is in source. Oh, Venv is in source. My bad. Okay. I just wasn't looking hard enough. Okay, your git ignore file does not necessarily need to be at the root of your project. I haven't looked at this in a little bit, okay? I wrote that to try to be clear. It's fairly common to have multiple git ignore files. Yep. There you go. We've already talked about this one. Here's the, let's see. We have already done this one, which is not ignored. Okay, so source, venv, bin, this one. Okay, this makes sense. Now we got it. Test.py, which one?
Which is not ignored. So here are the content. So it's in sort access.ignore, which is this ignore, so it will ignore only dev. Oh, so activate is not. So activate is ignore. That's ignore. Only dev is ignore because of this, so it's test.py.
Let's see. Test.py. That one's not even in there.
Okay. I think I need to do some reading. I haven't done any reading. It would be rough if the getting notified only accept exact file path section name. Luckily they don't. Let's go over some of the most common patterns. Why can't the character matches any number or character expect for a slash? For example, to ignore or.txt file, you could use the following pattern. This would ignore this would ignore files like princess diary, contact your mom.txt since they are above.txt file. Rooted pattern. Pattern starting with a slash are anchored to the directory containing the .ignore file. For example, this would ignore a main.py in the root directory but not in any subdirectories. Main.py. This ignore main.py but not source main.py since source is a subdirectory negation. You can negate a pattern by prefixing it with an exclamation mark. For example, to ignore all .txt file for the important.txt, you could use the following pattern. .txt. This would not ignore important.txt but would ignore self-affirmation important.txt. Comments. You can add comment to your .ignore file. Okay. Comment are especially helpful when doing some unconventional or complex, especially when collaborating. Order matter. The order of the pattern in the .ignore file determine their effect, and pattern can override each other. For example, temp not temp. Everything in the temporary would be ignored except for instruction. If the order were reversed, instruction would be ignored. Use this .git file located in the add the project root to answer this question. So ignore order.js, ignore the accept name.js, and ignore source. Ignore a file whose path is source content.md relative to the root project is ignored because of this.
There we go. We got it. Skill issues. I'm skill issuing. Come on, shut up. It would be rough if gitignore only accepted exact file path sections. Luckily, they don't. Let's go over some wildcard common patterns. Do the star gate patterns with prefixing with an exclamation. Save some notes or something. If you just want something ignored a certain way, you can do that. I found it really useful when it came to mono repos. So if you've ever done mono repos in with like Node or something, you want to be able to have a gitignore for each one of those repos. It seems to be really nice that way. So yeah, data directories, yeah, exactly. You just have like these little gitignores, so that way you don't have one giant gitignore that's super hard to figure out what the hell's happening. Instead, you can just do that. So it's nice. All right, assignment. Use this gitignore file to answer the question. All right, so that's a comment. We're gonna ignore everything with a text file except for the ones with name, and then we're gonna do source main and then content. Source content is ignored. So this one is ignored, source content MD, because this one is an exact file name that matches this one and is not anchored. So it should be is ignored. Let's go. Patterns. Yes, we already talked about patterns. We already did all this. What's the other question? All right, main.js.
Alright, .gitignore, the file location data root to answer the project. The file whose path is source main is relative to the project is ignored.
Yes, is main.js ignored? No, it's not, because that's a comment. It is not ignored. Let's go. Main.js. Is main.js ignored? No, it's not, because that's a comment.
Oh, okay, wait. Okay, main.py is ignored. What to ignore? We have talked about how to ignore file, but deeper question is what should you ignore? Here are some rules of thumb for coding project. Ignore things that can be generated, compile code, minifile, etc. Ignore the dependencies, not multi-tool, VNV, package, etc. Ignore things that are personal or specific to how you like to work. Editor setting. Ignore things that are sensitive or dangerous, such as env file, API key, and etc. Part deluxe. Let's ignore a generative file. We ignore generated file because they can easily be generated from the stuff we do to track. In this case, we are using Panko generated HTML and markdown file. Okay, brew install. Wow. Can I don't think I have it. Okay, let's do this. What is it again? Let's go to my Fedora. And let's do pandoc. Do they have it? Okay, they do. Let's try this. Sudo dmf install panda. Okay, run panda crimson c national sky web fix. Create a new file at the root of the repository. It's called advert content. So nvim advert.md. So this, okay, copy paste. Okay, run that. For fun, open the page on your browser to see nicely formatted markdown file. Okay. Run advert.html. Where is advert.html? Advert.html. Okay, right quit. That getting notified. Get remove cache. If you accidentally stage or commit by adding it to the getting notified, won't remove you remove it randomly. Okay, wait. I want to test that. Okay, get status. Let's do git ignore. I'm gonna remove this. Git status. Git add dot git status. Okay, it added that. Then I'm gonna fix my git ignore advert.md and then git status. Reset. Okay, git rm that cached. Wait, what just happened here? Okay, interesting.
Comment, it is not ignored. Let's go. Nice try trying to bamboozle my own questions. All right, here we go. They're trying to bamboozle me. All right, assignment. Part 2. We'll do that soon. All right, here we go. Let's ignore a generated file. We ignore generated files because they can easily be regenerated from stuff we do track. In this case, we're going to use pandoc to generate HTML from markdown files. We'll ignore the HTML files, but commit a markdown file. First, install pandoc. Brew install. I don't have that, but we do have this guy. I can't show you guys this screen. All right, here we go. There we go. Look at that. Look at how good that is. Look at how good that is. Fantastic. There we go. We installed pandoc. We can run pandoc version to see what that is. So I can go like this.
Wait, I want to do something. No, wipe. Full screen. Okay. I think this guy is the best in the programming sphere. I want to call like him though, how he navigates through each file folder. I know he uses NeoVim, I use NeoVim as well. But I wonder what kind of editor that he uses, and can NeoVim use the CLI command?
And then, all right, perfect. Secure, and then guilty pleasures. All right, and then let's see, with the message starting with M. All right, git commit. We got to do a little M message. So I get the question all the time, how do I have my developer workflow set up? And I thought,
hello everyone, today we're going to be taking a look at file navigation in NeoVim.
So I get the
since
question.
the editor is so extensible, there are a ton of different ways to move from file to file in NeoVim. And so today I wanted to cover my preferred approach and also contrast that with some other examples.
Git ignore my notebook pleasures. Okay, you don't know. You just don't even know how good the notebook is. All right. There we go. Nested git ignores. Oh, I actually already went through this. We actually talked about this exact thing, didn't we? Oh my goodness, we already did this. All right, which is ignored. All right, hold on. What are we doing here? Here's the let's see. Here's the contents. All right, we have these contents. Here's the contents, which is this source assets git ignore, which is going to be only devs and main.py. And this one's going to be bin activate. So that one's going to be this one right here. And this one's going to be only dev. And what's the other one? Main.py and main.py. Okay. Here's the contents. Wait. Then git add, git status, git add, git commit n. Was it n? Vim HTTP open. Does that work on? All right. So let's do advert that one while supplies last. There we go. Vim add. Let's go to this one, vim advert.md, paste all this stuff in. There we go. And then run the markdown. Let's see, run the following command to generate the HTML document from that. There we go, pandoc, bop, get status. So now we have this one, advert HTML. Beautiful. For fun, open up the markdown HTML and see what, let's see. We can do that. XD, I don't want to do that. We don't want to do that because I have to go like, I don't even think XGG open, does that work on? Look at that. Look at that beauty. Look at that beaut. Would you look at it? Would you look at it? There we go. We're gonna do a git ignore. I think I have to do a git ignore here. Oh, it doesn't technically say. So finally add the file. Oh, it's the git ignore. There we go. Vim git ignore. What is it called? It's advert.html. Bam. Git status up. Git status. Git status. So I think I should be able to do that. Nope. Do I have to add stuff? Finally, add the git ignore. Oh, and commit the change starting with n. Git add, git status, git add, git commit n. Was it n? Yeah. Foo bar. Screw it.
Wait. Okay. Git status, git add dot git status. So we modify that git ignore, and then new file would be advert.md instead of HTML. So we git commit dash m message n for nice.
But got him. There we go. I finished it. We finished the entire course just like that. I'm level 12. You wouldn't even understand what level 12 is. You wouldn't even understand it. What's your opinion on how organizations should handle PR merges into main? Squash, merge commit, or rebase? Which is most useful when you are responding to an incident? Which is the most useful for dev happiness overall in a prod environment? I mean, here we go again. I know. Here we go again. Damn. I'm gonna say it this way. I personally like to rebase and squash. I like fast forward merges. I like to be prepared for the eventuality I need to revert changes. That's it. Now, some people, it depends on your size. Honestly, if you have just a couple people, like, why even have a policy? I want to be real out there. Why even have a policy at all? Some people like to rebase, some people like to merge. Screw it, let it all happen. Do you really want to set up a whole bunch of red tape for you and one other person? Like, why add more shit to your life? Here, I'm gonna throw something out here. No matter what you choose, merge chaos, fast forward merges only, rebase squash, no matter what you choose, there will be a group of people that complain about it. So we're gonna start this one. So this one is a little bit different, okay? This one is a bit different. This one's gonna go over a bunch of like conflicts and stuff, okay? Hey, I know you're about to take Learn Git 2, and I really wanted to show you a couple quick techniques to make it a little bit easier, because inevitably you may mess up. At least some of you are guaranteed to mess up. You didn't read the instructions well. Maybe it's not quite as clear as it needs to be. And so these are two little commands that are gonna help you a whole bunch. So the first thing I'm gonna do is I'm just gonna show the contents of the previous commit. That's gonna show foo with a message of foo3. Now, every now and then you may have goofed up a little bit with your commit message and you just want to change it. You can go git commit amend. This will give you a chance to change your message, but as a warning, it does change your SHA. So obviously this is a destructive history altering item. It allows you to change the last commit's commit message. So if I go like this, git log one more time, you'll see now it's foo4, and you can see that. And if I go git foo, let's see, if I do two of these, you'll notice that there's not a foo3 in here anymore. Looking at the change, you'll see that all it is a new file called foo. Previous file was dev null, meaning there was no other file. So it's just a new file called foo with a single line called foo. Now, if I actually want to undo this commit completely, I can go git reset soft head tilde1. This will undo that commit. So now if I go git log just one line, you'll notice it's not that anymore. But because it's soft and it leaves changes in your index and work tree, if I go git status, you'll see right away, new file foo. Okay, we can work with this. Git reset hard would not only undo that commit by one, it would also remove the file. So if you ever have to say change something within a file, or you need to change the commit message, consider git commit amend, or consider git reset soft. Now I use actually git reset soft quite a bit when I'm doing a rebase merge conflict. This does happen every now and then where I'm rebasing and I go, okay, I fix all my changes, and then I actually git commit those changes as opposed to calling git rebase continue. If you make that mistake, you can actually use git reset soft head tilde1 to undo that commit and then rebase continue. It's kind of like it's a lot of IQ, and it's really, really nice. So I just wanted to give you those two tips because honestly, this course can be a bit meaty, and without these two things kind of fresh in your mind, you might accidentally find that you get yourself into a bad state and it's hard to undo. It's actually pretty easy to undo these bad states. The name is the Gitagen. All right, here we go. Let's do this. Let's get going. Okay. Welcome to Git Part 2. I wrote this also, where you learn how to use Git with a team. If you haven't taken the first Git course, I'd recommend starting.
Okay, I didn't know there's Git Part 2. Can I get the Git Part 2 somewhere? Course. Git Part 2. You have to be like a member or something? No, I don't. You know, I'm really like thinking of like being a member in here. Because I think they have like a great course, but
with it because it contains all these basic operations.
Welcome to Git Part 2. You will learn how you will learn to use Git with a team. If you haven't taken the first Git course, I recommend starting with Git contain blah blah blah. Okay. The stuff in the first course is great. Okay, assignment. Right. If you try to complete this course without SWL2, there's two SWL install distro less online. Type sudo termacurium run cs and download ASCII curium sudo apt. But running it though, it's ASCII curium Fedora. Oh, ASCII curium.
Operations, okay? The stuff in this course is great. Let's see, the stuff in the first course is great if you work by yourself, but you'll need more if you want to stand a chance as a developer at Megacorp.
I recommend using your K. This is the first part. Creating a fork. You need your own copy of a Megacorp starter repo. It will be used for the rest of the course. A fork is a copy of a repository. Forking a repository allows you to freely experiment with changes without affecting the original project assignment before. Navigate the Megafork repo. Press the fork on the bottom right. Okay, make sure the new... Yeah, there's something I wanted to do first of all. So here, can we do this, or is this like illegal? That node nardo.md, delete that thing. What is in that git ignore? Wait, what? Okay. So technically I don't need this anymore. For I'm gonna follow
where we sell synergism.
or maybe okay, I'm gonna try to do it myself first. Make sure your new repository is named. You can leave setting as default. Create pod Megacorp. Amendment. Create. What is a fork? When created a fork of a provincial Megacorp repo inside your GitHub account, it's a copy of the original that you can modify without affecting the original. You may have noticed that there is no manual for entry git fork. Forking is not Git operation, but it is feature offered by many Git hosting services such as GitHub, GitLab, and Gitbucket. Those services fork a repo by creating a new copy of the repo and associating it as fork of the original. It's quite literally just a copy that is linked to the original via some metadata.
CRM, customer relationship management solutions to enterprise. That's right, we do. Hey, look, I'm wearing the same shirt. I'm wearing the same shirt. What are the chances? This course assumes you've completed number 1, so you'll have all this crap that we've already done. We've already blah, 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 so we've already done that thing. Same shirt. What are the chances? There we go. I'm just going to run this because we've already done this, okay? We've run it. We've done it. You need your own fork of Megacorp starting repo. A fork is a copy of this one, so we need to go here. I'm going to first need to jump in here. I'm probably going to need to... can I fork? Or is it not going to allow me? I can't tell if it's going to allow me or not. Nice. Let's go. I've done it. Please select owner. Our fork already exists. Shoot. Okay. It's case sensitive. Today I learned it's case sensitive. There we go. I thought I just deleted that, but apparently I didn't delete that. There we go. And create. All right, we got the fork. We're forked out of our mind. All right, let's do this. Let's do this. All right, so we got a fork. We did that. We pressed the fork button. We did. Hey, look at that. Hey, look, that's me. Hey, that's me doing that. All right, boom, 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 boom. Run, check. Paste in your link. We're gonna paste that link. All right. There we go. All right, what is a fork? We created a fork of the official Megacorp repo inside your GitHub account. It's a copy of the original that you can modify without affecting the original. You may have noticed that there is no manual entry for Git fork. Git fork is not a real thing, right? Why? Forking is not a Git operation, but it's a feature offered by many Git hosting services such as GitHub, GitLab, and Bitbucket. Those services fork a repo by creating a new copy of the repo and associating it as a fork of the original. There's something called like a fork network or something like that with GitHub, which is very confusing. It's like one super repo, and there's some sort of thing that they do underneath That's a little bit more confusing. This is gamified Git tutorial. This is a Git tutorial I wrote and I'm going through. When you fork someone else's repo on GitHub, you simply clone their repo into your local machine. You create a new branch of the original. Well, technically, I think it has something to do with this in the fork creation network, but I don't really know how it works. Create a copy of your own, let's see, of the repo in your own GitHub account. Boom, let's go. That's what we did. All right. I'm not working, TC? No, okay. Git fork is a command line operation that takes no, false! All right, now let's clone it down. Let's clone make a core.
Okay, so you do need to clone it. Oh wait. Oh, I can do something. Okay. When you fork someone else's repo on your GitHub, you simply clone the version onto your local machine. Wait, create a new branch, create a copy. Okay, default is coming like false. cd github git clone git branch main. Want to submit the CLL text. Oh wait. Okay, then this disable read. Before we can drop into the course, we need to make sure that the read feature is disabled. We will learn about the read dust later in the course, but until then we are not ready to use it. Okay. PF on the forks. When you fork someone else's repository on a platform like GitHub, you get a copy of the repository in your account. This is a standard way to contribute to someone else's open source project. The steps are typically fork the repo into your account, clone your fork to your local machine, create a new brand, let's call it your feature, make changes, commit and push your fork remote to your feature branch, create a pull request, original made from your okay. Then the original owner can review your changes. If they like them, they can merge changes. Create a switch. Okay. Create and switch the new features called, okay, we could do git branch that c adds contrib. So we do git branch git switch contrib git branch. Wait, what happening? Switch. Okay. Okay, whatever. Add a file called, okay, make their contributors. Replace your GitHub on your actual account. Wait, replace your GitHub username with your actual GitHub username. Add a link to your profile to text file. Okay, new item tj.cpu.txt ls tj.txt add and commit your changes for expo. Do cd git add git status git commit -m add myself as a contributor. Push your changes up on git to that branch in your fork repo. Git push Well, git status, git branch, git push. Okay, I don't know what's going on.
RM, RF. Let's get rid of Webflix. Let's get rid of Webflix local. Let's get rid of Megacorp. Git clone. ThePrimeagen. Git clone. ThePrimeagen. Megacorp. Vim. We're in. There we go. Perfect. All right. We're in. Okay, so let's start doing this whole thing, because this is the one that involves a bunch more stuff. When you fork someone's repository, like a platform like GitHub, you can copy a repository into your account. This is the standard way to contribute to someone else's open source project. Steps are typically fork the repo into your account, clone the fork to your local machine, create a branch, your feature, make the changes, commit the changes, create a pull request. Bada bing, bada boom. You're probably asking yourself, why should I fork a repo instead of cloning it? Cloning is a lot easier. Well, that's a good question. You first have to answer the question: am I interested in contributing back to the main line, or do I just want to peruse the repo? If you wish to just simply peruse the repo, then a clone is just fine. Whereas if you wish to contribute to the open source project, then it does require a fork. Here's usually my workflow when it comes to forking and making changes. 1, I just fork the repo. 2, I will clone down my forked repo. 3, I'm going to make the changes to my main branch. 4, I'm going to push my changes up to my fork's main branch. 5, I'm going to open up a PR with my changes from my fork onto the original repo, along with a nice detailed explanation of what I have changed and why. And finally, I get rejected, go home, cry a little bit, skill issues, but nonetheless, I tried. And that's what really counts, doesn't it? It's also worth noting that whenever I clone down my fork, I also add a second remote that I call upstream that points to the original repo. And the reason is that when the original repo changes, I can bring in their changes. And that way, when I fix something, I know that I'm fixing on the latest version. I'm not accidentally fixing something somebody else has already fixed. This also avoids having conflicts during PRs. And if you wish for your PR not to be rejected, here's some pretty helpful hints. Number 1, whenever I make a PR, before I hit that button and say, make it live to everybody, I review my code on GitHub. This weird thing happens to me. Whenever I review code on GitHub, I seem to catch things that I don't catch when I'm in my own environment. I kind of think of this as editor blindness. You're so used to everything that when you see it in a concise, different way, you just see mistakes you've made so much easier. Probably most importantly is make sure that I seem to your PR not to be rejected. Here's some pretty helpful hints. Number 1, whenever I make a PR, before I hit that button and say, make it live to everybody, I review my code on GitHub. This weird thing happens to me. Whenever I review code on GitHub, I seem to catch things that I don't catch when I'm in my own environment. I kind of think of this as editor blindness. You're so used to everything that when you see it in a concise, different way, you just see mistakes you've made so much easier. Probably most importantly is make sure the maintainers want these changes. Spend the time looking through the repo's issues, make sure you've searched and validated that this really is an issue, and if there's no mention of it, open up an issue. Tell the maintainers you're willing to fix it and see if they want your fixes. You may find that maintainers actually do not wish for you to participate, or others, they may want you to fix it but in a completely different way. As long as you're polite in your communication and you're very clear as to what you're trying to fix, you will find that often maintainers are very happy to have you come on board and help out. Okay, so assignment. I want to make sure people know how to do this. Okay, I want to make sure people knew how to do this like fun little bit. Add a file in your forked and cloned version of Megacorp to the repo contributors directory. The file should be named, let's see, your GitHub username.txt. Replace your username with a good one. Okay, let's see. Add myself to the contributor. Okay, bam, 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 bam. Let's go in here and go in here. Okay, well, I'm already there. ThePrimeagen.
Okay. Oh. Okay.
Text. Oh my gosh. Oh my gosh. All right, there we go. There we go. We got that. Let's do that. Let's go like this. Git add git. Whoopsies.
Wait, is he doing it in the correct branch?
All right, there we go. So we're gonna push this up, right? So I'm gonna do all this. I'm gonna push this up, push my changes to my GitHub to an add contrib branch. Oh gosh, git checkout.
Git switch. Wait, git branch. Okay, so we do git switch, that's c add contrib. ls git status git add dot git git. I'm gonna need a correction. So git add dot git commit dash m. We added myself to contrib.
Out, add contrib. Oh, I'm not supposed to use checkout. Sorry, it's just I can't help it. I can't help that I do.
Git push origin add. Git push origin add contrib. Wait, okay, I'm gonna some. So when I do git push, why do I need to say git push origin and then some message? Why can't I just do git push? I feel like next time I should type out origin at the branch name every time, especially if you already told Git which branch you're working on. The reason Git push failed or asked for more information the first time is that Git is designed to be highly flexible. It doesn't want to assume where you want to send your code or which remote branch send your code. Okay, I mean, what's gonna happen now then? We do here, we go here, we make the absolute by default a new local branch has no upstream target. When you run git push origin add contrib, you're telling Git you are telling Git two specific things: where the remote server name origin, what the local branch add contribute, how to skip the extra typing. You can actually make git push work by itself for the future updates. You just need to link branches that you git push your origin. Huh. Bang. What now? You need to seek in something out. Can be bothered. Friday the 1st, I am awake. I am doing my coding.
I do. Add contrib. Oh, I'm not supposed to use checkout. Sorry, it's just I can't help it. I can't help that I do. Who the hell does that? Noob. Noob! Noob! He's a noob! I'm not even sure. Oh, I copied it from the Boot.dev site. Remote add origin. All right, there we go. Fixed. Fixed. You wouldn't understand. Fixed. You wouldn't understand. You don't understand because you're a sore loser. Boom. I think it told me to create a pull request. Let me just make sure that that's what we're doing here. All right, there we go. All right, with the pull request open, submit the test. All right, there we go. Run all checks. Let's go.
Wait, okay, so and then we need to go to boot. Okay. Wait a minute. How do I do the pull request? Pull request. New pull request. Name branch base main tag. Oh, wait. I don't understand how to redo the pull request.
Fixed. Fixed. You wouldn't understand. Fixed. You wouldn't understand. You don't understand because you're a sore loser.
Okay, tag. Pull request. New pull request. What? Did I? Wait, then why can I do any pull request? This is Boot.dev mega collapse comparing changes.
ThePrimeagen. All right, there we go. Who the hell does that? Noob. Noob! Noob! He's a noob! I'm not even sure. Oh, I copied it from the Boot.dev site. Remote add origin. All right, there we go. Fixed. Fixed. You wouldn't understand. Fixed. You wouldn't understand. You don't understand because you're a sore loser. Don't understand because
okay,
you're
is this?
you're a sore loser. Boom. I think it told me to create a pull request. Let me just make sure that that's what we're doing here. All right, there we go.
Okay, no conflict. So what I could do now is place a link to your public GitHub. Okay. Maybe something like this. Submit all check. Oh, sync your GitHub. Okay.
All right, with the pull request open, submit the test. All right, there we go. Run all checks. Let's go. Owned it.
Refold.
Head. Mean where me at now. For those that don't know who Grug is the best. I always go down here and I just read this line whenever I think of Grug. Apex predator of Grug is complexity. Complexity bad. Say again, complexity very bad. You say now, complexity very, very bad. Given choice between complexity or one-on-one against T-Rex, Grug take T-Rex. At least Grug see T-Rex.
Give me 1 second. Okay, I'm back.
Complexity bad. All right, let's go like this. Okay, for example, you should be on main branch of your local clone of your fork of Megacorp repo, which means head is pointed to the main branch. Like all things in Git's Eternals, head is just stored in a file right here. Manually check to see what's in head. Yeah, let's do that. Cat git check out main git cat dot git. I think it's
Git switch master. I said git switch main. Okay, cat.git head.
stored in a file right here. Manually check to see what's in.
If you haven't deleted the branch, if you haven't already deleted the branch, so cd branch -d git branch dash d add on trip. You should git branch cls. Okay.
Head. Yeah, let's do that.
Cat
Cat git check out main git cat dot git. I think it should be the name of the thing. There you go. Yeah, it's just a path to the branch or the tag, if I'm not mistaken. Gat. Yeah, you gotta get it, baby. You gotta get it. Get that son of a bee. All right, let's see if that just works. Okay, what did I didn't read. All right, what's the thing? Oh, git branch d add. I must have missed deleting that. Did it say to do that? Okay, my bad. I didn't look. I did not, in fact, look. We're going to grug no read. All right, git reflog command, pronounced reflog, not reflog, is kind of like git log, but stands for reference log, and specifically logs the changes to a reference that have happened over time. The default one is the head, by the way. Grug no read, grug never read. Where head is now, 1 move ago, 2 moves ago, 3 moves ago. You are already familiar with how git log works, how it shows your current branch and all the history of the commits. So if I had a brand new repo with 3 commits, A, B, and C, and I execute log, I should see the following output. And if I execute reflog, I should see this following output. Is reflog just a verbose log? Well, no, it's actually not. It's very, very different. And to illustrate the point, let's remove commit C. I can remove commit C by using git reset. I can walk back 1 branch, and as you can see with git log, I now only have B and A. But if I use git reflog, you'll notice that I don't have 2 entries. I actually have 4 entries. I have A, B, C, then back to B. And notice that it contains the command I used to get to B, which means that if you need to get the contents of C, you can actually use some of the plumbing of Git plus reflog to be able to retrieve back out the contents of C, even though it's gone from your branch. I cannot tell you how many times reflog has saved my bacon by walking back and getting some commits that have been long forgotten. So what is reflog? Well, the definition from Git SCM is reference logs, or reflog, records the tip of branches and other references whenever they are updated. Or in layman's terms, reflog tracks the changes of a branch or other references being head. This means as you move your head around from branch to branch or from commit to commit, it tracks every last little step. I personally only ever use reflog to look at how my head has transitioned over time and rescue out a commit if I need to. All right, assignments. Run git reflog to see what its output is. All right, here we go. Git reflog. Look at that. Look what it is.
Head. You will see a big scary git called head branch, reference to the commit, and head is reference to the branch. You are currently on all of this to say is grug speak. Grug? What is grug? The grug blind root of layerment. Imposter syndrome. Grug note that such imposter feeling in development always grug 1 of 2 state. Grug is ruler of all survey. Viol cloud cup or like grug have no idea what to do. Grug is mostly latter state. Most time hide it pretty well. Now grug makes software of much work and moderates open source sources. And yet grug himself often feel not any idea what doing. Very often, grug still fear, make mistake, break everyone's goal, and disappoint the other grug imposter. It is maybe nature of programming for most grug to feel imposter and be okay with its best. Nobody imposter if everybody is imposter. Any young got ready so far? Okay. Who is this written by? Conclusion: you said complexity very, very bad. Book. This is gonna be a prank, right? Okay. Yeah, I.
Going from add contrib to main, from main to add contrib, to this commit, to the clone. Cool, right? You get to watch it kind of move around. It's kind of cool. I like it. Reflog is nice, and it's really not all that bad. All right, switch to a new branch off of it called slander. Git switch C Slander, look at that. I remember to use that. Let's see. Create a new file called slander.md and have this one. All right. Vim slander.md. Paste that in. Megacorp CEO Lane enjoyed the live action Last Airbender movie. This Megacorp CTO PrimeaGen is a fan of The Notebook. Okay. Lane may or may not have had a little bit of fun editing some of these things. Okay, I don't know if I didn't choose all of the stuff. I'm just saying, you know, The Notebook's not a bad movie, okay? What? I don't know if I didn't.
Wait, I wasn't like paying attention. Okay. Git refolk command. Pronounce reflog. Not reflog. Reflog. It's kind of like git log but stand for reference log, and especially log the changes to a reference that have been over time. Ref log uses a different format to show the history of the branch or head. One that's more concerned with the number of step back in, for example, head, where head is now head 1. Git ref log head. Check out moving from add country to main. Commit myself to country. Check out git clone. Switch to the branch. Switch to the new branch. Okay, git switch that c slander. Run git refolk again. Head is pointing to the print batch. Head. Check out moving from main to slander. Okay. Create a new slander.md. Add this. Oh. Right quit. Commit with a new message file. Git add slander. Git commit dash m. Call it b slander. Git ref log. Head now is a commit b slander. Okay.
Choose all of the stuff. I'm just saying, you know, The Notebook's not a bad movie, okay? What? I feel. I even have to commit it. Okay, it's not bad. Okay, it's not bad. The movie was a good, terrible movie too. Did you cry? I didn't cry. I'm not crying. Slanderous filth. I'm not even sure if I spelled slanderous right. Boot.dev, run that. Okay, what am I not even doing here? All right, expected this. Contains all this one. Oh, I had to do b.slander. Goodness gracious. Reset, soft. Head. Okay, I gotta start reading. You guys are not helping me. B slander. You guys gotta quit. But by the way, did you see that nice usage of git reset soft? Huh? Did you like it? I could have git commit amend. I could have. We could have amend. But this one is great. Okay, it's okay. It's okay to cry. I don't cry. I work out. I know we could have amend. Okay, but we didn't. Okay. Delete branch. Have you ever ship?
Ship a bug to a production main branch. Ship a bug to the production main branch. Oh, it's not an assignment. Delete branch. Have you ever ship a bug to a production main branch? Create a new branch to fix the bug. Fix the bug and commit the changes. Switch back to main branch. Accidentally delete the fix branch. Yeah, me neither. Assignment. Switch to main branch and delete slander. Git switch main. Git branch that the slander. Okay, so you delete your branch. Git reflog. Git cat file dash. No, okay. Git log all Okay, use GitHub to look where your head has been. Find the commit hash that will correspond to the changes. Check out moving from Slender to man. E standard, so it has to be this one, right? And then we want the tree, and then the blob readme slender.md.
A bug to production, main branch, created a new branch to fix it, bug fix, fix the bug and committed the changes, switch back to main, accidentally deleted the fix bug branch. All right, switch back to main and delete your slander branch, git branch D, whoopsies, git check out main, git branch. Oh, I'm supposed to use switch, but I cannot use switch, okay? I can't use switch. I can't use switch. All right. I want to use switch. Boomer brain, I know. So you've deleted your branch that had a unique commit on it. All is lost, or is it? Remember, git reflog keeps track of where everything has been. So let's do this, git reflog. Look at this bad boy. That's where we did this one. Look at this commit right here. The commit's right there. The commit is right there. Okay, that means what we could do, like here's one way to do it, which I'm not saying this is the way you should do it. I'm just saying this is one way you can do it. You can go like this. You can go like this. You can go git cat file -p. Remember when we learned about all of this? And you can actually go through all of the little internals and snatch out the slanderous file, git cat file -p. Look at this, right there. There's me, enjoying the notebook. Right, we were able to plumb through things if you wanted to. If you wanted to get deep in there and kind of go through the whole thing, you could. So there we go, we grabbed that. And so we can actually grab this and do that and do a recovery message, right? So I could do this, right? There's other ways I could also do stuff, right? This is just one way. You could also git merge. And since I already have this thing, I could actually just merge over that change into it. We're not gonna do it, but you could imagine we could do that. So instead I could just take the contents of this one file and I can remake it if I wanted to as well. Even though it's not true, commit that file with b recovery, git add this.
Okay, we can copy this and vim slander.mv right quit git add dot git commit -b recovery and
Commit -b recovery. Boom. Confettied out of my mind. All right, cherry pick would have been what I would want to do. Really? I would have just merged it over. Right? I mean, it just depends. Do you want the history or do you not want the history? Like, what happens if there's 10 commits? Then you have to cherry pick all the commits. Let's see. Using git internals is exceptionally inconvenient. We had the copy and paste from cat file 3 times. I would not recommend doing it this way. I just wanted to drive home that at this point, you can always drop down to the plumbing commands if needed. Luckily, there is a better way. Git merge. I just haven't talked about cherry commit. That's why we haven't talked about that. So I can do reflog this one, find the commit, that one. So I can do git cat file, do all this crap, which we don't want to do. I can also do this. Right? I could have just merged over exactly what it said from reflog, right? Let's see, do I still have that reflog thing or did it open it in one of those windows? I think it did one of those windows, right? Yeah, do I do no pager? No page. I can never remember what that line is. Oh, that's right. You don't do it there. It's a git no pager. There you go. So as you can see right here. So I could actually do git head at the second position back, right? Why does our git reflog allow us to potentially recover commits on deleted branches? Because it keeps a record of where the head has been? Yes, that's what it is. There you go. Little fun reflog stuff. Merge. All right. Well, okay, let's see. What can you merge with? Only tags, commits, branches, a commitish. Commit, tag, reflog entry, anything that can resolve to a commit. So that's why you'll see me use the term commitish quite a bit in this course. All right. Working with Git is a dream when all of the developers on the project are committing changes to different lines of code. Things get a little hairy when changes are to the same lines are made at the same time. One commit isn't the parent of another. Let's break some stuff. Remember, Megacorp is enterprise CMR service backed by the power of Git. Essentially, it means that we store lists of customers' data in a Git repo. Truly cutting edge stuff. You should be on the main branch. Create a new branch called Add Customers. All right, Git branch. No, wait, it's Git. Is it Git switch? See, there you go. All right, there we go. We got that one. And we're going to grab this one to custom.
I think we done this. Merge conflict, yeah.
Branch by the power of developers on the project. Oh, that's right. You don't do it there. It's a Git no pager. There you go. So as you can see right here. So I could actually do Git head at the second position back. Right? Why does our Git rev log allow us to potentially recover commits on deleted branches? Because it keeps a record of where the head has been? Yes. That's what it is. So there you go. Little fun ref log stuff. Merge. All right. Well, okay, let's see. What can you merge with? Only tags, commits, branches, a commitish. Commit, tag, ref log entry, anything that can resolve to a commit. So that's why you'll see me use the term commitish quite a bit in this course. All right, working with Git is a dream when all of the developers on the project are committing changes to different lines of code. Things get a little hairy when changes are to the same lines are made at the same time. One commit isn't the parent of another. Let's break some stuff. Remember, Megacorp is enterprise CMR service backed by the power of Git. Essentially, it means that we store lists of customers' data in a Git repo. Truly cutting edge stuff. You should be on the main branch. Create a new branch called Add Customers. All right, Git.
Add a customer to add the following. Wait, add the following line to the end of customer slash all
branch. No, wait, it's Git. Is it Git switch? See, there you go. All right, there we go. We got that one. And we're going to grab this one to customers CSV. All right.
Oh, ls cd customer ls and vim all CSV book.
All, is it all like that one? Yeah, there we go. So we're going to add it to all customers, and then we're going to also do orgs partner.
Additionally, org cd org. Then commit the changes with the commit name C. Okay. Next, switch back to main. Git branch main. Oh my god, Git branch Git switch main. git. Okay. ls cd customer. Boop, boop. That. Okay. Git add dot git commit m.
Text right there, boot and startup. So we're gonna do orgs partners.text. There we go. Beautiful, we've done those two. Commit your changes with the thing C. Okay, we're gonna kind of cruise through these easy parts because I assume at this point you guys understand adding, committing, doing all that, because this is all easy stuff, right? None of this stuff is crazy, all right? Git status, git add this, git commit. I think I said C, right? Yep, C. Such Carson, much HTMX. All right, there we go. And now we're gonna switch back to main and we're gonna do this to customers. Git check out main, go back to here, edit this thing, jump up here, customers all, add JSON gross, HTMZ contributor. Git add this, git commit. What do we need to do with D? That's right. D. JSON is better than Carson. JSON gross, HTMZ contributor. Git add this, git commit. What do we need to do with D? That's right. D. JSON is better than Carson. More like Carse off. All right, so do you see what we've just done here? Do you see how this is going to cause problems? So if I go like this, git log one line dash p one main, you'll notice that I edit customers with one line right below company title. If I do the exact same thing, but I do it with the add customers branch, you'll notice that I do the exact same thing to the same customer files in the same location. In other words, we both modified the same line. And by modifying the same line, Git doesn't know what to do because Git doesn't understand anything about code. It only understands things about modified lines. If two lines have been altered in some way, it creates a merge conflict. There we go. I believe that should just work. There we go. I believe that should just work. There we go. And let's go conflicts. Yeah. So merge conflict occurs when two commits modify the same line and Git can't automatically decide which changes to keep and which change to discard. Consider the following commit history. ABC, this is pretty much what we have now, except for it's A, B, C, and D. The main branch has something like this. Is nice, returns this one. The feature has this one, is nice, 420. Right? If we try to merge feature into main, Git will detect that the return line was changed in both branches independently, which creates a conflict. So this is good. This is good to understand, right? When a conflict happens, usually as a result of merge or rebase, Git will prompt you to manually decide which changes to keep. It's okay when the same line is modified in one commit and then again in a later commit. The problem arises when the same line is modified in two commits that aren't in a parent-child relationship. All right. If the line changed in B was all the conflict by change in B's parent A, the HTMX guy writes an essay about it. That's true. Carson will probably write an essay about it. That's perfectly fine. Git knows A happened.
If a line changes in commit B, but was also recently changed in B's parent commit A.
First, then B. Yep, that's the thing. You can't conflict yourself like that. Right? You just can't. All right, if two developers on separate
Wait, I feel like I need
result
to
of merge or
rewatch
rebase,
this.
Git will prompt you to manually decide which changes to keep. It's okay when the same line is modified in one commit and then again in a later commit. The problem arises when the same line is modified in two commits that aren't in a parent-child relationship. All right, if the line changed in B was all the conflict by change in B's parent A, the HTMX guy writes an essay about it. That's true. Carson will probably write an essay about it. That's perfectly fine. Git knows A happened first, then B. Yep, that's the thing. You can't conflict yourself like that. All right, you just can't. All right, if two developers on separate branches modify the same line of code, what happens when the branches are merged? HTMX guy relaunches the project with a new name, fax. It's perfectly fine, false, conflict arises. There we go. Assignment. It was stupid Greg, who merged his new customer data into main, commit D, while you were working on your new customer data in add customers branch commit C. Because his change made it into main first, stupid Greg, it's up to you to resolve the conflict, stupid Greg. Now, because your manager is a Luddite that learned to code before version control was invented, he asked you to merge instead of rebase. Absolutely. This is all true.
Now, because your manager is a Luddite that learned to code before version control was invented, he asked you to merge instead of rebase.
Switch to your add.
Wait. Yeah. Git switch. Add customer. I have two branch, right? Okay.
Add customers branch and merge main into it. All right, there we go. We should get this one. Let's go. Git check out add customers. Hey. Git branch D add contrib. Wait. Why is contrib still there? I thought I just deleted it. Why is there multiple add customers? Whatever, that's confusing. Whatever, I don't got time for this. Damn it, Greg. Leftos potentially mentioned. Git merge main. All right, boom, we got ourselves a conflict, okay? If we run git status, you can confirm that we're in a conflict. So if I go git status, you can see right here, you have unmerged paths.
Wait, okay. Git merge main. Conflict, okay.
Fix the conflicts and run git commit and use git merge aborts to abort the merge. So we can actually stop the merge by doing that. Get out of here. Okay, there we go. Git run status like this to confirm that you're in a conflict. We can see that. So let's run.
Git status. On the branch, you have unmerged path. Fix the conflicts. Use git merge status about to abort merge unmerged path. Git file modify CLV.
This thing. Boom. Oh, wait, what?
Git merge into main. Wait, am I? What does it say? Okay, wait a minute. As I mean, it was a stupid Greg who merged into his new consummation. Okay, okay. Switch to add consumer merge main into it. You should get a scaling merge. Automatic merge failed. Yeah, we get that right. Automatic merge failed. We configure the result. You have unmerged file. Run the CLR. Run the submit. Okay.
Oh my gosh, this thing is incorrect. Lane, we have a problem. This is wrong. Our direction somehow got out of stuff here. I know. Which means like this: git merge abort, git check out main, git merge add customers. There we go.
Okay. Git merge dash abort. Git switch main. Git branch. Git merge add customer. Okay.
There we go. Kind of BS. Git check out main, git merge. Lane, we have a problem. This is wrong. Our direction somehow got out of stuff here. I know. Which means we go like this: git merge abort, git check out main, git merge add customers. There we go. Kind of BS, Lane. All right, here I'm gonna go back here. I'm gonna report this. Wait, does it? Am I wrong here? Maybe I just didn't. Hold on. Git merge abort. Git merge abort. Git check out. Maybe I did this wrong. Yeah, I used the wrong one. Lane, it's not right. Lane, you're right. You're right this whole time. I'm the bad one. I'm the bad one. Merge abort. Git merge abort. Git check out. Maybe I did this wrong.
Oh my god, git merge.
Yeah, I used the wrong one. Lane, it's not right. Lane, you're right. You're right this whole time. I'm the bad one. I'm the bad one. I'm the bad one. Shut up. Git check out, you dumb fuck. I know, I messed up. Isolate the changes and merge correct. You merge yourself correct. Resolving conflicts is a manual process when they happen. Git marks the conflict files and asks you to resolve the conflict by editing the files in your editor. So here we go. Open up the customer's all and you should see this. All right. So here we go. Here's our customer. So you can see you can see a couple things here. Just so everybody knows, in a merge conflict, this represents hours is the top one. Hours is where our head's at. Here's the change in hours. The change ends with the equal sign. And then this is the one, and then the bottom one represents the incoming branch. Theirs. So theirs is main, ours is head. And this is the change in theirs. This is the change in ours. Okay?
So,
it's pretty good to know those things. All right. Let's see. Delete the conflict markers and leave both changes and Greg's change in the file. It should look like that. So you can actually have both changes at the same time, right? Nothing says you have to change it. It's up to you to resolve how to do this. You can accept both. Totally reasonable. Save file and do this. Okay. Yeah, we can accept both. There's nothing that says you can't accept both. Of how to do this. You can accept both. Totally reasonable. Save file and do this. Okay. Yeah, we can accept both. There's nothing that says you can't accept both. Right?
Pretty cool.
All right. Resolution. After manually editing any conflicting file, sometimes it's more than one file or more than one section of a file, you simply need to add and commit the changes. This tells Git that you've resolved the conflict and can continue with the merge.
Wait, what happened if I do git status now?
Okay. Awesome. We can do that. So let's resolve with this nice message right here. It's a nice, beautiful message. Git add this, git commit -m, all of that.
Git add this, git commit -m, resolve.
Oh my goodness, stupid Greg. Oh no. All right, there we go. Apparently, I don't know how to do that. There we go. Got it. All right, there we go. Apparently, I don't know how to do that. There we go. Got it. First try. And now we can do log to examine the homework. You should see C and D, and commits come together and E commit. All right, git log one line. Look at that beauty. And then we can go one line graph. There you go. It all comes together in E. We resolved the conflict. Bada bing, bada boom. Very nice. Absolutely liked it. Absolutely enjoyed that. All right. All right, you just ran git merge, and you're now seeing this. Okay, I just realized what was happening. I was like, wait a second. Which code in the conflict is yours, and which is theirs? So if we ran...
Okay, if this is ran git med and now you're facing a conflict head med, which code in the conflict is yours and which is theirs? The top one is theirs, the top one is mine, and the bottom is theirs.
Git merge, that means this is ours, this is theirs. The top is mine, the bottom is theirs. It's all mine, stay away. I prefer that answer, honestly. All right, you just ran git merge, and you're now facing this conflict. Oh, let's see, what does head referred to? It's another name for the master branch? No. It's another name for the main branch? No. It points to the latest commit in the other branch you're comparing to? No. It points to the current branch's latest commit. Boom. It's pointing to where head points to. Everybody knows that. It's that easy. Back to main. Your manager at Megacorp is not happy. It turns out you were never supposed to add customers to the all.csv file at all. Only Greg is allowed to do that. Stupid Greg. This is what you get from making changes without 10 design meetings and an alignment of stakeholders. What were you expecting? To be productive? This is Megacorp. Process over productivity. Get back in line. I don't want to hurt anybody's feelings. But at the same time, I know a lot of people just got bruised by that one statement. I'm sorry. I'm sorry that, right? There's some of you that hurt. That paragraph hits home? I know it does. Let's just say I've written a design document for the dumbest thing. Stakeholders are okay in the 10th design meeting, but have problems when the implementation hits prod. Always. Every single time. Assignment. Let's fix our hastiness by doing a git reset hard of the merge commit. This will allow us to take a different approach to resolve the conflict. Luckily, we haven't borked main yet. We just need to fix our add customer branch. While on add customer branch, reset to commit C. All right. customer branch. While on add customer branch, reset to commit C.
Okay, let's figure out hesitated by doing get reset how to merge commit. This will allow us to look at a different approach. Luckily, we have broke main yet. We just need to fix our add confirmation and why only get.
Need to fix our add customer branch. While on add customer branch, reset to commit C. All right. Let's do that. Oh my goodness. Let's go like this. Let's go. What is it called? Megacorp? Yeah. Get reset hard.
Wait.
Head tilde 1.
Oops.
There we go. We're back to C. Everything is great.
Wait.
We're looking good. We're
D is there. We are here. So we split the mush. Okay.
feeling good. There we go. We do all that nice stuff. So I literally just took the change, moved back my branch once, and discarded my index and my work tree changes. Bada bing, bada boom. Easy peasy, pumpkin seedsy. That's just that. All right. Let's fix our hastiness by doing a hard reset. Yeah, we already did that. Luckily, we haven't borked main yet, so we'll just fix. All right, here we go. Try merging main into customers again. This time, resolve the conflict by keeping only the changes from main. I want to see something because I may accidentally have re on, and if I do, then it's going to say it's all fixed. Nice. I don't have re on. Git config list global
Git merge main.
grep re.
So we can do custom all CSV, then keep only thing in main.
Oh, I do. Wait, shouldn't re take care of that? Doesn't wouldn't re jump into that? Am I confused here? Am I being what? What? I thought it did. Well, then why didn't it should have auto conflict it?
Bang.
Record resolution was solved. Was added. Weird. Why didn't it auto resolve right here? Shouldn't it have just auto resolved? Oh wait. Oh my goodness, I am so stupid. I am so stupid. It did. It automatically using previous resolution. So if I go to customers, oh my goodness, I'm so dumb. Look at this. The conflict is gone. The reason why the conflict is gone is I knew I had re enabled. So since the customer doesn't have a conflict in it, we need to disable re git config. I'm just gonna do a local one. I'm just gonna go like this: add local re enabled false. Right. So I'll just add a local one. So I still have my global one. So it still continues to do what it's doing. Git merge abort. Then git merge main, which should now, there you go. I now have the conflict without re taking over, and I should be able to just go into here. And I should be able to go to all, and now we have this again. So now this time we're supposed to select Greg's change, which is theirs. So I can go like that. Boom, Greg's change selected. There's some other ways you can do that make it easier, but this is good. So we're gonna go like this. Find Greg, have this one. Boom. We're gonna go here and go git status, git add this, git commit -m with that one. There we go. And then jump in here and do that. There we go. There we go. All right, I think that's good. All right, ours versus theirs. In a merge conflict, ours refers to the branch you are on, merging into. Theirs refers to the branch being merged. This is important. Git merge their branch. Ours is the branch you're on, right? Git terminology. Last time, we manually edited the conflicting files. This time, let's use Git's built-in merge resolution tools to make the use of the terms ours and theirs to refer to the branches being merged. You should currently be on add customers with this kind of history right now. Switch back to main and merge add customers into main. This would result in
Switch back to main, then merge add customers into main.
A fast forward merge, bringing C to E into main. Delete add customers. All right. Git check out main.
Wait. Okay. Git switch main. Git branch CLS.
Git merge add customer.
Git merge add customer. Fast forward. Okay.
Git branch delete add customer.
Git add git branch dash d add custom
customers.
what did
Boom.
we just
Look
do?
how fast I am. All right, so let's do an ours versus theirs merge, because this is really good to know. All right, so we got a multi-conflict so far. We've only dealt with one conflict at a time. That's small potatoes. Let's see what happens when we have multiple conflicts to resolve. All right, so let's switch to a new branch off main called delete rec.
Okay, switch to a new brand of main called git switch that c delete records. Okay, git branch just did test. Okay, now we go to customer all SCV and then delete this. So delete that. It should have only the heading line, and then we want to go in the original partner list, the startup. So git add dot git status git commit dash m. We want to call it f, and then git switch main. It did the customer all, but this time just change the line. So we'll change the line to that, and then commit the message git add dot git branch. Okay, and then we do git add dot git status git commit dash m. This one is g. Bada bing bada boom. Check out conflict. We have manually edited the file to resolve conflict, but it turned out Git has some built-in to help us. The git checkout command can check out individual changes merging during a merge conflict using the there's or our. Our keep the version of the file from wait. So there's two flags here, theirs and ours. Our keep the version of the file from your current branch. Okay, the one you are on before merging. There's just the version of their branch. Okay. While on main git branch. Okay, I'm on main. CLS git branch. Resolve the two conflict we have edited. Keep theirs, keep ours. Prime
records. Git switch c that. And then let's see, edit customers all and delete the JSON line. Okay. There we go. Deleted it. Edit org partners and delete the boot.dev record. Okay. Org partners. There we go. Boot.dev record. Boom. Oh, we want to keep the line. There we go. Let's see. 6.
Oh. Okay.
let's see, switch back to main and edit customers. Oh, commit the message with F. We got to commit the message with F. Git status. So I'm gonna use what's it called, fugitive for this part because it's just easier and faster, and you guys don't really care about committing, right? What do we need to do? Delete those records, right? I just prefer that. Git check out main. Just makes life easier being able to use that because we can move faster. There we go. All right, so we have this one. So edit the orgs partner and add a Boot.dev record to Sales Inc. Oh, change it. And change the Boot.dev to Sales Incorporated. Yeah. So I can go like this, Sales Inc. There we go. We did that one. So now we should have this one and do a G. There we go. And CCG such Inc. There we go. We now have that one. Run and submit the test. There we go. Wait, is that all we had to do? Did I miss something? Add a Boot.dev record to Sales Inc. Oh, change it. Fugitive for this part because let's see, switch back to main and edit customers. Oh, commit the message with F. We got to commit the message with F. Git status. So I'm gonna use what's it called, fugitive for this part because.
What is this fugitive thing? He is talking about fugitive. What is that?
It's just easier and faster, and you guys don't really care about committing, right? What do we need to do? Delete those records, right? I just prefer that. Git check out main. Just makes life easier being able to use that because we can move faster. There we go. All right, so we have this one. So edit the orgs partner and add a Boot.dev record to Sales Inc. Oh, change it. And change the Boot.dev to Sales Incorporated. Yeah. So I can go like this, Sales Inc. There we go. We did that one. So now we should have this one and do a G. There we go. And CCG such Inc. There we go. We now have that one. Run and submit the test. There we go. Wait, is that all we had to do? Did I miss something? I thought we were doing multiple. Oh, we forgot to do that. We forgot to do that one. Carson Gross. That's right. All right. Customers all and go Carson Gross. Go in here. S. There we go. So I just did right there. For those that don't know, I just did a git commit amend no edit. And so by doing a git commit amend no edit, I simply just I know I wrote shut up. It just means I merged in that change, right? So I merged in that change right there, and I did that one. You know, because I'm not gonna lie to you, it is very nice to be able to use the tools I'm used to. You know what I mean? I don't always do everything via the command line. There we go. All right, so we did all that one. We have these nice commits. Now we have these two things, and so now all we have to do is just cause the conflict. Let's go. Wait, what did I do? Oh my goodness. Here, I forgot to do that. There you go. I'll show you what I did. Git status. So I have this one. Git add this one. Git commit amend no edit. There we go. So I kept the same line, just not everything else. Wait, what am I doing wrong here? Carson Grows, HTMX creator. What? I'm not good at reading. Okay? I've never said that I was good at reading, all right? First try. Let's go. First try. Check out the conflict. We've manually edited files to resolve the conflict, but it turns out Git has some built-in tools to help us. The git checkout command, can check out the individual changes during a merge conflict with theirs and ours flag. While on main, merge delete records. All right, git merge delete records. So now we...
Wait. Hold up. While on main, merge.
We should have two conflicts. You can see, can check out the individual changes during a merge conflict with theirs and ours flag. While on main, merge delete records. All right, git merge delete.
Oh, okay. Get merge delete records. Conflict.
Record. So now we should have 2 conflicts. You can see the 2 conflicts right here. Get status. You can see the 2 conflicts right here. Unmerged path. Both of those. Get diff should show each one of them having the problem right here, which means that I can go like this. How do we do this? We're going to keep theirs for customers all and keep ours for partners. So I can go like this. Git check out theirs.
Git check out.
That's going to be customers. All. There we go. So now I have theirs, and then ours is going to be orgs partners. There we go. So now if I go like this, git diff, you'll notice that we have no changes. Everything looks good. Git status, perfect. Git add this. If we look at them in here, you'll notice right away. There we go. So that's the deleted one that we kept. And then from orgs and partners, you'll notice that we have Sales Inc. from our side. So Sales Inc. from our side, deletion from their side by using git checkout theirs and ours. It's pretty nice. What do we need to do here? We need to do this with an M H. Let's see. Such resolution conflict. You'll also notice something else. Notice that orgs is not a part of any changes here. Do you see that? There's no orgs a part of changes. That's because that wasn't changed. By accepting my change, this commit doesn't contain any change. Does that make sense? Because that file only had one change to it, which was my change. So by me accepting it, the difference between these two goes to 0. It's good to know. So that's why sometimes those things can change and it can look a little bit confusing. It's actually not all that confusing. It just means that something goofed up. Oh my goodness. How am I so bad at this? Oh. Oh yeah, let's go. All right, something you may have noticed when resolving merge conflicts is that you don't get the standard merge commit message, right? No, you don't. You have to manually provide a message. Typing, it actually makes sense when you think about it. Git doesn't know what you did to resolve the conflict, and it's encouraging you to document your change via the message. That makes sense, right? I think everybody understands that. What commit message is used after resolving that? The standard one, unhinged commit message. For example, we should have rebased instead. I actually like this one. That's my favorite one. But we'll do a custom commit message.
Okay, I've been coding for nearly 2 hours. I'm gonna take some breaks and then we'll see whatever later. Okay, so yesterday did not manage to finish the video, but today surely. Yeah, I got distracted. Yeah, I was helping roof and well later. Like wins today, I did not walk to watch it, so yeah, but
branch, create a new branch called add customers. All right, git branch. No wait, it's git. Is it git switch? See, there we go. All right, there we go. We got that one, and we're gonna grab this one to customers a CSV. All right. All, is it all like that one? Yeah, there we go. So we're gonna add it to all customers, and then we're gonna also do orgspartner.text right there, boot and startup. So we're gonna do
rebase conflict. Yeah.
We'll do a custom commit message. Now we're gonna do a rebase one. This one's gonna be a good one. All right. Rebase, full disclosure, a lot of rebase's bad rep comes from conflicts. Fear not, it's nothing you can't handle with just a smidge of practice. Rebasing feels scarier because it rewrites Git history, which means you are not, if you're not careful, you can lose work in an unrecoverable way. But as long as you understand what's going on, it will make your and your team's Git history cleaner and easier to understand, and more so, easier to revert when needed. it is impossible to revert your change with several merge commits and all that. I've seen some pretty nasty ones where you're trying to do that. Assignment. Create a new branch called band, copy of main branch, and add a new file, customers band. All right, there we go.
Okay, git branch. Okay, git switch main git branch d at classic. Wait. Mm-hmm. Okay. Switch back to main, and then we go customer and banded CSV, copy this, right? No. Right quit git add dot git commit dash m j. There we go. And
Skibidi toilet merch when git check out dash b band. I didn't use switch. It happened. But we're gonna keep on going for it. Band.md. Is that what it was? No. Band.csv. Boom. Put it in. Yeah. Sam Controlman. Closed AI. Classic. Really true. Absolutely actually true. There we go. So we have this one. We're gonna do git message I. So I'm gonna go in here. CCI control man. There we go. And so now let's go like this, git check out main, do one of those. And then how do we want to do here? We want to have the same Sam controlman, but a different one of these. There we go. And then jump up here and go C, H. Oh no, wait, J. You're right. H comes before. H before I, except after C's. Right? Is that how it goes? I'm on chapter 7, section 4 right now. All right, well, let's go. All right, so there we go. So we have all this one. So we should be able to run this to make sure it's all actually the way we want it to be. So I'll go like this. We'll run this bad boy. It's going to do all this. Bada bing, bada boom, bada bing, bada boom. All right, beautiful. We are just crushing through this course, okay, people? We're feeling good. Make the conflict. Before we move on, I just want to remind you that it is often, not often, that you'll be creating your own conflicts. We're doing so because you probably don't have any friends to practice with. I don't actually, kid, Arch users. But even if you do have many developer friends, let's just make all the changes ourselves so you don't need to bother them. Let's see, you switch to a new branch, fix bug, which is just a copy of main. While you're fixing the bug, someone else merges their changes to main. You fix the bug and it happens to edit the same file. You open up a pull request, rebase, fixing the mains, Git tells you the conflict, you resolve the conflict, you complete the pull request. This is like standard operations, right? We all know this one. So we switch the band branch, rebased it into main. Which rewrites the Git history of band branch, because remember, it needs to add that extra commit. So there we go. We're going to do that. All right. So we're going to go like this. Git, check, out, band, right there. Git, rebase main. My gosh, we have a conflict. Look at that conflict. Oh, no. Oh, no. So if I go in here, I look at my status, you can see right here.
So you are currently using rebase Git.
We have problems, don't we? We actually have problems. All right. Well, you should get a conflict. You might also notice something odd. This time, head pointed to main's change rather than band's change. All right, so let's just jump back for a quick second and just validate this, and I'll explain why. All right, so notice that this should be band, protagonist should be main. Look at head, has protagonist, which is main's change. Why is ours mains, even though we did a rebase on band? Why isn't ours our change? Why is it main's change? Does anybody know? The commit comes from main? No, because that would make it theirs. We move to main, then replay our commits on it. Boom, let's go. So this is from section 1. This is why section 1 is so important, is when you rebase, your target branch becomes your branch that you're on, and then you replay the source branch's commits starting from the merge base and forward at the tip of your target branch. Therefore, let's write this out because it might be a little bit easier to visualize. So this is the most important part. Remember, so when I'm on band and I do git rebase main, what happens is I actually check out main, which is going to be at the tip. I grab the differences between band and main, and then I do band. You know, if there's multiple commits, I'd actually attach each one of them to the front. So that'd be like band 1, band 2, band 3, right? So I'd get them all on there. So my branch now looks like this, where the tip of main is now the new merge base, as opposed to wherever I branched off before, which could be somewhere in the history. So that is why ours is theirs and theirs is ours during a rebase conflict. It's actually not confusing if you know how rebase works. It makes perfect sense. It's that you have to switch branches and then play the commits. All right, let's see what happens here. Let's see what our assignment is. Switch to the new branch, do this. Copy a branch and add the new file customers, this. We've already done this. All right, there we go. Assignment, switch to band, rebase on domain. While you should get a conflict, you might also know something odd. We already talked about why. If you had merged main instead of rebase, head would still point to band. Correct, because merge does not swap replay. It just adds or creates a merge conflict into a single point. There we go. That's good to know. However, you kind of need to think in reverse with rebase. Theirs represents the band branch, which in reality is our change. So we're going to run branch. You'll notice that you're not on a branch. That's right. That makes perfect sense, right? Because remember, it has to create this no branch situation where it takes main and then starts applying commits to it. So you're in a no branch situation, right? There we go. Bam, look at that. Look at that confetti. Man, first try. The same git checkout theirs and git check ours commands we used in merge can be used to resolve conflicts during a rebase. You may have also noticed that if you open the file in your editor, depending on your editor, it has UI features to help you resolve the conflict. Yep. So this would be VS Codes. Accepting incoming changes is the same as checkout theirs. Accepting current changes is the same as git checkout ours. That would be in theirs. I don't know how to use VS Code. All right. Assignment. Use the appropriate git checkout command to overwrite the band branch's changes with the changes from main. So since it's main that we want, git status, git checkout ours. Our branch. Remember, we're taking main. All right. There we go. Let's see, and then hit him with the rebase continue. Git rebase continue. we go. And then we git log to see the new commit history. Git log. Look at how good that looks. Look at that. Look at how good that looks. All right. You may have noticed something. Did anyone notice that I was gone? Why was I gone? So theirs is main. No, ours is main during that situation. The number of rules indicates that this isn't intuitive. No, it just means that it can be potentially complicated. Anything that is sufficiently complicated requires you to learn. If you only worked on things that are intuitive, you would never use recursion. Like, that's that. It has nothing to do with it being, the number of rules have no indication whether it's intuitive or not. Understanding the underlying reasoning why or what happens makes it intuitive to understand. I understand how rebase works. Therefore, ours versus theirs is intuitive to understand. But that's because I have a understanding of what's happening. Expected state to contain this. Wait, hold on. Branch. Oh, I'm not. Oh, I haven't. Git rebase continue. Oopsies. Did I not get status? Did I not?
Okay, so you have to get me back on Git add. This is very basic. So what is happening now? Git branch.
There we go. We've continued it. Git status. Awesome. All right, let's do this. Perfect. We're in. We did it. Why did the deleted commit? What happened? Why was I gone? So for those that don't understand, so where's I? Why is I not in here? Why was I gone? So for those that don't understand, so why?
Like git one line all versus parents.
Where's I? Why is I not in here? The reason why I is not in here, remember this, is that I was a change where deleted a specific record. And what do? We ignored that one change. By ignoring the one change that I was, we've dropped the entirety of the record. Since there's no empty commit. When the commit is empty, the commit is dropped.
There's no empty commit. Okay, now for the rebase, right? Get the go to the web link. Get log online. Yeah, we do it here. Git branch. Git switch. That's go ban that. Git branch. Okay, we could go nvim main.csv. If I paste it here and put this line as well, right? And I right quit ls, we have that, and then what I'm going to do is copy this git switch main, git switch main, git okay, sure. Wait, why do I have this? Shouldn't I not have it? Okay, whatever. We do git branch, git switch bandit, git svit, git switch bandit. Then we go npm bandit csv. Okay, we have that, and git switch master. Then go nvim main.csv. What? This is it's a different branch, right? Still have git switch bandit, switch to the bandit. I don't understand. Wait. How come I still have bandit? Okay, this is okay, whatever. Okay, now let's try something. We do git switch.c, and we do test re. Okay, we go test re git branch. We are now in test re, so we do nvim test.csv, and I'll copy all of this. Right quit, then git dot git commit dash m. We do add that csv to branch. We added at git status, git branch, git switch main, switch main, git. So yeah. Then wait, what do we call it again? Like test re git branch test re ls git branch git switch test re ls test.csv. Git branch man, then git switch main, then we do nvim test.csv, right quit, git add dot git commit, and add that csv to main. Now here's what we're gonna do. We're gonna go into the git switch test the rebase, then I do git rebase main. We have some conflict. Git status. Now we could do go in here and we said okay. So we could do git and we do git checkout. Error, you need to merge. Git checkout hours. Git checkout hours. Git add dot git status. Git rebase continue successfully. So git log line all here. Add that CSV to main. So we lost the added CSV to branch.
Right? Yes, we are working on the band branch. We started a rebase of band onto main, meaning we're rewriting the history of band to include all the changes of main. We effectively removed all the changes of the I commit by choosing to keep the changes from main instead of band. We continued to rebase, and Git realized that the I commit was pointless because we're rewriting history anyways, just remove it. There's literally nothing in it. Right? There's no I in team, that's why. If our changes had been more complicated, say we kept some of the changes from I commit and overrided others, then Git would have kept I in the commit history. Why did Git remove our commit? Because this is Megacorp and we have a strict no commit policy. Because rebase is scary and it should be avoided at all costs, because it was essentially empty and rebase is okay with rewriting history. Bada bing, bada boom. There's nothing to commit. There's nothing there. It's just making life easy, right? What if the only part of the commit had been undone during the rebase conflict? What if only part of the commit had been undone?
Okay, what if we resolve it there? Git branch, then git switch that C test. Git okay npm 23.md test. So if we have something like this, right? Okay, let's do something. So here it will be food list. Let's do oat milk, some chicken, rice. Okay, we right quit that. We do git switch main, git branch. Hey, what do you call? Git switch. No, git branch. Oh, yeah, I can do this. Then git switch main, switch to main. Then we do nvim onto m. Git add dot git commit dash m, add that to test. Git switch main, switch back to main. Now we do nvim 122.md. We're just gonna say the same food list. Now we're gonna do like a PC, laptop, just make it like just to test something out. So we do git add dot git commit dash m, add that to main. Now we do git switch test. We do git switch test, git rebase main. We have some conflict. Then 123.md. What happens if we do this? Remove this, right quit, git status, and then git rebase dash continue. You must git add dot git status git rebase dash continue. We do fix the conflict with git status. Okay, git log. Okay, what happened here? Added CSV to main, added to fix the conflict. Add CSV to main. Okay, so when we rebase, we kind of lost that one anyway. But in this case, at least we have I mean, we have some part from the branch and some part from the main. Added to main. Wait, this is the head and fix the conflict. Fix the conflict. This is the. I'm guessing this is like the merge. No, this is the head for the. I don't get it. Wait. You explain to me when I switch my branch to the main, why is the head for the main added to main? Shouldn't it be fix the conflicts? Because I rebase from the branch to the main and then I fix the conflicts. I git add dot and then I merge it together. But since I use rebase initially, shouldn't it all just be like one line? Might complete number to be tripped up by this git rebase is one of the initialize. To answer your question, rebasing update the branch you are rebasing update the branch of the branch you are rebasing. You git rebase check out the test branch. You essentially take my new commit on, pick it up and place it on the latest main. This is the X. Git took your test commit, which is wait, 9 BC. Pause and notice that there's a conflict on new main. Here, where you get from. The resolution, you manually fix the conflict in due to empty added a file and ran git rebase continue. The result. Git successfully created a new commit. A. Yeah. Fix the conflict to replace your old test commit. You place it right at the top of the test branch. I didn't move. because you were on test branch rebase. Git only update test branch pointer. It leaves me exactly where forward to catch up. You like the quick command for fast forward your main branch would catch up with the same pointer. Git switch main git merge test. There we go. Okay, so when I'm on in the test branch and I use git rebase main, what does it actually do? I thought git rebase main will take everything from the test and then point the latest commit of main to the test. You have it exactly backward. Okay, sure. When you're on test branch, you run git rebase main. You are not moving main, instead you're moving test. This command git rebase main, it was then take the branch I'm currently on and establish main as its new base. This is the exact step by step of what Git does under the hood when you run that command. Find the split. The split G. Git look back throughout your history and find common actions there. The common action that has originally branched off the main. Set aside of your reg. It takes all the commit you made on test, since that split and temporarily save them off to the side in keyboard and space. Start moving the moves that starting line. Git instantly fast forward your local test branch so it points to the exact same spot as the latest commit on the main. Replay your commits. Git take your saved test commit and pop them down one by one on the top of the, because Git essentially rewriting your commit on the new base. Okay. Even though the code changes it. Think of it like building a Lego brick. If main is a blue tower,
then the commit would have still been, let's see, would have still been removed. No, the commit would have remained in the history. Let's go on to this one. Okay, let's clean up our branches. Remember, during the rebase of band onto main, we actually discarded the changes of band, which actually means that band is now just identical to main anyways. So yeah, so we're gonna switch back to main and delete band, right? Git check out main git branch d band. There we go. All right, so let's delete some branches. We're gonna delete git a branch. Okay, we did that one. And now let's go over here. Let's go. There we go. All right, let's move on. All right, disable or re. Well, it should have already been disabled. This section does need to technically go back because I already did a local one of those. I don't think I deleted this. I'm not sure if I even have it, but here, I'm gonna get rid of it just in case, right? Repeat resolution setup. A common complaint about rebase is that there are times when you have to manually resolve the same conflict over and over again. This is especially prevalent when you have long-running feature branches and even more likely multiple feature branches that are being rebased onto main. Re to the rescue. The git re functionality is a bit of a hidden feature. By the way, this is directly from Git SEM. Can you believe that? One of the most useful features of all time.
I can't scroll up to
it's
look.
Just
I want to be able
hanging
to scroll
out
up to look.
Here, hold on. Git re. There we go. Let's go Git SEM. Look at this. Functionality is a bit of a hidden feature. Wait, you're telling me I didn't have to resolve it every time? Yikes. The name stands for reused recorded resolution, as the name implies. As the name implies, it allows you to ask Git to remember how you resolved a hunk conflict, so that the next time it sees the same conflict, Git can resolve it automatically. In other words, if if enabled, a re will remember how you resolved a conflict, applies to rebasing but also merging, and will automatically apply that resolution the next time you see the same conflict. Pretty neat, right? Am I right? All right, assignment. Create a new branch off of main called faves. All right, Git. Check out B faves. Didn't you switch? Suck it. New commands. Create a file called
Okay, repeat resolution setup. A common complaint about rebase is that there are times when you have to manually resolve the same conflict over and over. This is when you run into long feature branch and or likely multiple feature branch that are being based into main. It really is a function. The git read functionality is a bit of a hidden feature. The name stands for reuse record resolution, and as the name implies, it allows you to ask Git to remember how you have resolved a hard conflict, so that next time you see the same conflict, Git can resolve it for you automatically. In other words, it enable will enable how you resolve a conflict applies to rebasing, but also by that resolution and the same. Okay. Now we add this and right quit. You commit git commit -m v2k. Then git switch back to main. And nvim customer grab.m. Paste this. Git add dot and change this to L. Bang bang. Enable re. Okay. Oh. Switch to fab. You should see git switch.
faves.md with the following contents. Let's go. Jump back in here. Go here. Go here. Wait. Customers. Okay, customers. Faves. Faves.md. There we go. Cool. Commit that with message K. Create a copy of faves branch called fave2. All right, here we go. We'll go in here. We're going to go here. We're going to CC. We're going to K. My faves is the highs. And go in here. We're going to go here. We're going to K. Create a copy of faves branch called fave2. All right, here we go. We'll go in here. We're going to go here. We're going to CC. We're going to K. My faves is the highs. And right, boom. Boom. Git check out -b faves2. So now we have the same branch twice, okay?
Did I do something wrong? Create a copy of a branch config. Yeah, I'm just gonna.
Okay, the same branch twice. All right. Now we're going to switch back to main and create a file called faves with different content. All right, here we go. Git check out dash b main git Manny main. Oh crap, I created Manny. Git check out main git branch d Manny. Got him first try. And then go in here and put that in there and git status, git add this, git commit dash I. What is it called? Should be with an L. Take the L. Take the L. Bam. All right. So now we have these right here. We have main on L, faves on K, faves 2 on K. The changes from L and K naturally conflict. Run the test. Let's go. We're going to run the test. We're running the test. Let's go. We're running it. Confettied out of my mind. Are you ready for the confetti out of my mind? Enable the re feature by running the following command. All right, so I'm just going to go like this. Git config unset local re enabled because I have a git config list grep re. There you go. I already have it globally true for everything because I like the setting. Switch to faves and rebase it onto main. All right, git check out faves, git branch or git rebase main. There we go. So notice this. We're gonna do this conflict. We're gonna be doing this recorded pre-image for customers. So there we go. We're getting ready. We're re-in. Okay, so we have a conflict. Let's do this. Let's solve this conflict. Notice how there. Let's see. Hold on. Accept both changes. All right. Let's accept some changes. Okay. E. Yes. 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 Changed. Git. Add this. Git. Rebase. Continue. All right. So now what are we gonna do with the naming? Stage and rebase. Leave the commit message as K. All right. Boom. Got it. Note that Git may automatically open a file on your editor in which you can edit the commit message. Simply save and close and continue. When you're done, you should see something like this. So you should notice that we should see something like this. Recorded resolution. Recorded resolution. Yeah? We're read out of our mind. We're read out of our mind. Now, switch to faves 2 and rebase main, it onto main. All right? Git check out faves 2, git rebase main. Now look at this. We have a conflict, but it's already resolved. Right? It's already resolved because we already resolved this specific commit. So now we don't have to resolve it again. It already knows what to do. It already knows what to do. So now I can do the exact same thing. I can do the whole git rebase continue. So re is really, really nice because it's one of those things that if you do it right, it is fantastic. Why is re disabled by default? Because it can lead to confusion. So if you don't know what it is, it's probably dangerous to have it created. What's foot comes with re? Let's say you have a change that results in a conflict, but you want to resolve it differently. But instead, it automatically resolves it for you. You could feel pretty confused, right? So that's why it's nice to have it as a feature you opt into, because that way you don't accidentally screw it up. All right, let's go on. Merge back in. Phew! Now we have 2 branches, faves and faves 2s, that are ahead of main in the same way. We don't actually need both faves and faves 2, so switch back to main. Try deleting fave 2 with lowercase d flag. Now actually delete it with capital D. I'm not sure if we've actually done that. Git check out main. If you don't know, if you try to delete a branch that ends there, it terminates your commit history. It'll be like, yo, you probably don't want to do that. And so you have to give them the old capital D. And when you give them the D, it then does it. Then merge faves into main. This will result in a fast forward merge. Deletes the faves branch. There we go. Git merge faves. Git branch D faves. Boom. Let's go. Grab it. Paste it. All right, accidental commit. Let's see, how with merge conflicts, you can commit the resolution, but with rebase, you have to do continue. Dude, I've done this so much in my life. I cannot tell you how many times I've done this. Dude, I know. I'm telling you, which is me telling me.
You know how with merge conflict, you commit the resolution, but with rebase.
I cannot help this one. How do you undo that? Dude, Dude, this is the greatest thing in the universe right there. This solves that problem. If you ever you've never done it, really? Oh my gosh! When I get rebase, when I resolve a conflict, I do git add dot. It immediately I go git add rebase or git commit dash add, and I commit it, and I'm like fuck, and I just hate it. But if you just do a reset soft, remember a soft takes the commits changes, applies them to your work tree, and moves your branch back one, so you get your rebase right there. Now, I believe this has been largely fixed. I believe now you can actually do a rebase, continue even after you've committed it, and it just works. You just get that new message instead. Before, it used to not work. I love this one. Why does git reset help you if you accidentally commit during a rebase? Because you can undo the commit and continue the rebase. Yes, exactly. That's why I love it. Okay, we're gonna go over a quick bit of squashing, okay? Every dev team will have different standards and opinions on how to use Git. Some teams require all pull requests to contain a single commit, while others prefer to see a series of small, focused commits. If you join a team that prefers single commit, you'll need to know how to squash your commits together. To be fair, even if you don't need a single commit, squashing is useful to keep your Git history clean. Yes, and it makes it easy to revert. Again, if you have a feature that could be dangerous in production and it's spread out over 12 commits that have like 18 merge commits, it is really, really annoying versus just having one commit at the end. Squash it, easy to put in, easy to pull out, okay? What is this squashing exactly? Well, let's see, it's what it sounds like. We take all the changes from a series of commits and squash them into a single commit, okay? All of them, A, B, C, D to AX. Easy. Assignment. Let's get ready to squash some commits. Push your current changes up to your forked repo on GitHub.
Wait, I'm curious. If I go to GitHub, right, and we go to the mega thingy, and if I go to look at my activity, what kind of commit do I see? I just see the L, so I didn't see every single commit. Is this like squash? Oh, okay. So it's like something like this.
Just in case your machine goes swimming. Don't skip this. Okay, here we go. Git, push, origin, main, go. All right. Create a new branch off main called temp main. Git, check out temp main dash B. Let's go.
What's that? What? So git branch git switch that C, we go temp main.
All right. So now that we have that, we do all this. Let's go. Let's go. We're back in. To be completely fair, I mean, I am just absolutely. I have what someone. Oh, git check out dash B temp main. Yeah, there we go. All right. How to squash. Perhaps confusingly, squashing is done with git rebase command. It may not be intuitive, but remember, rebase allows you to apply or reapply history. This will make sense more. Here's the steps to squash the last n commits. Start an interactive rebase with git rebase head or slash or dash I. I think they call it tac I in the military. Git rebase tac I head till the n, where n is the number of commits you want to squash. Git will open your default editor with a list of commits, change the word pick to squash or S, save and close the editor. The I flag stands for interactive and allows you to edit the commit history before Git applies the changes. Head till the n is how we reference the last n commits. Head points to the current commit. There you go. Does that make sense? Why does rebase squash? Remember, rebase is all about replaying changes. When we rebase onto a specific commit, head till the end, we're telling Git to replay all the changes from the current branch on top of that commit. Then we are using the interactive flag to squash those changes so that rebase will apply them all in a single commit. Assignment. Megacorp executives do not like your last few commits. As a result, your manager told you to squash the...
So I think my plan for today is like do squash, do stash, okay, do reword, and then for the rest, I feel like I'm just gonna go cook some food and then watch throughout the day.
Last three commits.
Yeah, for the reword, at the end of the squash, I'm gonna do some thing and then
commits J, L, and K into a new single commit message. J, redacted. Squashing is destructive operation, which is why you've decided to make the change to temp main before moving it to main. While on temp main, squash these three. Don't forget to pick or squash it and edit J redacted. Let's go. So I'm gonna go like this: git rebase. Oh, first git log. So we want to go all the way to J. So
wait, okay. Git log one line.
So 1, 2, 3. Git rebase I head tilde 3 to J. So 1, 2, 3.
Mine case is 4.
Git rebase I.
Git rebase. That's
head tilde 3. Let's go. I always go like this. There we go. You'll notice right here, it says it right here that let's go. I always go like this. There we go. You'll notice right here, it says it right here that you can do that. S stands for squash. Use the commit and meld it into the previous. So that means S, let's see. How does this go? It goes this, let's see, this one goes into the previous, and then this one, I forget exactly how these things end up, but either way, it ends up good. I forget the exact merging order. Redacted. Right? There we go. There we go. So if I go git log, one line, you can see that J is redacted and the rest are all right there. Perfect, right? But they still can change the change set. So if I go -P, it still has the whole change set. It just doesn't have, what's it called? It just doesn't have the individual commits. All right.
Do this. What's wrong here? Why can't I do it? Resolve the conflict when you remark them. You haven't done anything wrong. You just
Over it. Now that temp main is in the state you want, and hopefully you verified that with git log, we need to do what the boss asked. Delete the main branch, rename the temp branch into main, ensure that the temp main branch is gone, resubmit. Now, obviously, this is a very dangerous operation. We're rewriting public history. We're doing it just for fun because, hey, why not? But we're doing it, okay? So don't do that, by the way. Branch, delete, main, git, check out, don't actually do temp main main. This is dangerous, okay? There we go. We did some naughty stuff. We squashed main, which means that because our remote main branch on GitHub has commits that we removed, Git won't allow us to push our changes because they're totally out of sync. Git push has a command called force flag, which allows us to override a remote branch with our local branch. It's very dangerous, but useful. Flag that overrides the safeguards and just says, make this branch as same as the branch. So by doing this, we're actually changing that stuff. And that could be, obviously, you would never want to do this to a main, okay? Just so you know. Go ahead and force push your local main to the branch on remote main. I know. By the way, you should never actually do this, okay? This is crazy, okay? Squashing is scary. When you squash commits, for example, ABCD and into a single commit, you're removing history from a project. So all the changes are still there, but the individual markers of each changes are gone. It's one big commit now. In the last few lessons, we erased all the commits, meaning we can't go back to the individual checkpoints anymore. Or you can't go back easily. We can still use git plumbing and reflog to actually rehydrate everything and re-put it back into it. We can, but we're just currently not doing that. When you squash commits, you lose history of the individual commits. That's what happens. You can still get it back. It's just that it's just non-trivial, right? When you squash commits, the content stays the same. Correct. The content stays the change. It's just that you change the commits. Yeah, never squash master. Never squash master. I put that in there so I could talk about it and why it's crazy. We did some weird things. Squash commits to main. Now let's do a common thing. Squash all commits on a feature branch for a pull request. If your team prefers single commit pull requests, we will likely be your workflow. Create a new branch off main. Go about your work. When you're ready to get your code into main, squash all your commits into a single one. Push your branch to the remote one. Open up a pull request. Merge it once it's approved. All right, assignment. First, let's just do points 1 and 2. Megacorp needs to add a new feature to the content management system. Specifically, they need a script that will automatically scan for sensitive information in the repo. Create a new branch, add scanner off of main. All right, this is where things are going to get a little bit wild here. Git branch or check out -b. I know it's switch. I don't want to do it. I don't want to do it. I'm too much of a Luddite. All right. In the scripts directory, there's a file called scan.sh. Replace the to-do comment with this. All right. I can't help it, okay? All right, in the scripts thing, scan F8, write the script. There we go. We got it. All right, there we go. We have that one. Run the code from the root repo. All right. Look at that. We have, oh my gosh, we have so many social security or credit cards. So many cool credit cards just flying everywhere. Finally, now we can do social security numbers, add another few lines to the script. All right. There we go. Run the script again to ensure it works. Oh, did I not? Oh, I forgot to commit. Oh, I forgot to commit. I forgot to commit. Hold on. Okay, credits. There we go. Wait, why isn't that working? Oh, did I accidentally delete? Oh, crap. All right, there we go. Now we can paste this in. There we go. All right, there we go. So now I can go CC, and this one should be J, right? This should be L. Yep, okay, so this one will be L. This one will be social security numbers. My bad. My bad, I accidentally did that one out of order. Now we should do phone numbers. There we go, add one for phone numbers. Added it for phone numbers. There we go, there's some phone numbers in there. CC, and this is HJKLM phone numbers. There we go. Looking good. Run the script one last time, make sure it works. There we go. All right. I accidentaled your commit. I know. It happens. There we go. All right, so we got ourselves set up for this nice next one, squash series. Remember, the full workflow we're going to be doing, which we already talked about this. Creating your branch, making your commits, squashing it, making a pull request. Let's tackle point 3. Squash KLM into a single new commit starting with K. Remove LNM. All right, so do it again. Git rebase I head tilde 3. Do these ones. SS. There we go. And go into K. There we go. Bam, 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 bam. Got those two. We are rewriting the history of our own branch. Let's see. To make it look as if we did all the work in a single commit. This is normal and fine because it's our branch. Yes, it's our branch. Now it's okay to do. Right? Now it's okay. Before it wasn't okay to do, and we did it on main, which we shouldn't have done it on main, but it's gave me something to talk about. Gave me a reason not to do that. Our branch. All right, so now we're going to do 4 and 5. Use git push to add scanner and open a pull request. All right, git push origin add scanner. There we go. We're going to do that, and we're going to go to backend. We're going to go to GitHub, ThePrimeagen, which update Mega Corp, and there we go. Pull requests. New pull requests. Add scanner. Let's go. Create pull requests. Create it. Let's go. Looking good. Looking good. Oh my goodness. How do you not have my repo name? I thought you had it. All right, I'm just going to copy that one and bring it back in here and go ThePrimeagen. There we go, and run all checks. Oh, am I doing it? Oh, to main on your Megacorp. Oh crap! I did it on your Megacorp. I didn't read the instructions good. I in fact did not read good instructions here. I in fact did terrible instructions reading. There we go. Apparently I can't change where my remote is pointing to, which is kind of weird. That's fine. GitHub, ThePrimeagen, Megacorp. There we go. So I effed it up. Apparently the UI doesn't let you change the base. Reading instructions are required for squares. Yeah, it's losers. Add scanner. There we go. Sorry, the previous one didn't required me to do it on a different one, so it got me a little bit confused. All right, there we go. Merge the pull request. Remember, we did all that one. Now let's tackle point 6. Merge your pull request from add scanner into main. You can also do so by clicking the big green merge request button. When you're done, you switch back to main branch locally. Here's the scary part. Delete your local add scanner branch. Pull the latest changes from main, and your local main branch should have now commit K. Yeah, some people get freaked out. It's okay. When you have centralized merge stuff, it's not a big deal. Hit the big green button, confirm the merge, git check out main, git branch, big D delete, add scanner, right? Boom, get it out, git pull. Oh my gosh. I didn't set that. There we go. Git pull. My branch wasn't pulled. There we go. Look at that. Good? Yeah. There we go. We got the energy. We got it all done. Absolutely fantastic. It's all in. All right. Wait, did that mean I did it? Okay. Stash. All right, so now we're going on to stash. Are you guys ready for some stash? All right, you've been at Megacorp for a while, 3 whole days, and to your mother's surprise, you're still employed. Here's the workflow you've been using as a junior developer. Commit some changes to a feature branch. Open a pull request from that feature branch to main. Check out the new feature branch and start back to the next task. Today, however, is a big day. All right, today is a big day. Let's see, big day. Let's see. The customers are complaining about a critical bug, and the CEO saw you first. She asked you to drop everything and fix it immediately, but you've got a bunch of unstaged changes that you're not ready to commit yet, and you don't want to lose. What do? Many Git noobs would create a second clone of the Git repo. At this point, a huge mistake. You're better than that. That's right. You are better than that. The git stash command records the current state of your working directory and the index staging area. It's kind of like your computer's copy-paste clipboard. It records those changes in a safe place and reverts the working directory to match the head commit, the last commit on your current branch. To stash your current yet, and still employed. Wait, did that mean I did it? Okay. Stash. All right, so now we're going on to stash. Are you guys ready for some stash? All right, you've been at Megacorp for a while, 3 whole days, and to your mother's surprise, you're still employed. Here's the workflow you've been using as a junior developer. Commit some changes to a feature branch. Open a pull request from that feature branch to main. Check out the new feature branch and start back to the next task. Today, however, is a big day. All right, today is a big day. Big day. Let's see. The customers are complaining about a critical bug, and the CEO saw you first. She asked you to drop everything and fix it immediately, but you've got a bunch of unstaged changes that you're not ready to commit yet, and you don't want to lose. What do? Many Git noobs would create a second clone of the Git repo. At this point, a huge mistake. You're better than that. That's right. You are better than that. The git stash command records the current state of your working directory and the index staging area. It's kind of like your computer's copy-paste clipboard. It records those changes in a safe place and reverts the working directory to match the head commit, the last commit on your current branch. To stash your current changes, do git stash. Yeah, and stash list to list your changes. Don't look at that. My stashing workflow looks a little something like this. I usually have some amount of work that's in my index or my work tree, and I get a request in that says, hey, can you please investigate this bug? Or hey, you need to pull in the latest changes, because if you pull in the latest changes, the feature you're developing will have a couple extra APIs that you need. Which means I'm gonna have to take my changes, create a commit, pull in the new changes, finish off the change I wanted to make, create another commit, then squash those two commits into one, or I could just stash my work tree and my index, pull in the changes, and then pop off my stash when I need to get back to doing what I was doing, and finish the change I was trying to make. Now, the times that I don't do that approach, the times that I don't choose stash, which often I do, is whenever I had to pull in a change, but I'm already in several commits into a change I'm trying to make. Typically, I try to keep my changes pretty small, but every now and then you'll have like a 1,000-line change. And whenever I have a big change like that, I try to make small commits along the way as nice checkpoints in case I screw something up so bad that I can just roll back to the last known working commit and then start again. So if that happens, I simply make another temporary commit, rebase in my changes, and then at the end of everything I'm doing, I already have worked in that I'm going to squash everything down to one commit anyway, so it doesn't bother me. All right. Assignment, while on main, update readme.md in the root of megacourt repo to do this one. Bam, bam. Just after updating readme that the CEO approached you, stash the changes. Once you're stashed, make sure that they are safe in your list. Let's see, that they are safe by listing. Now it's okay to be able to see a single stash list. Okay, all right. Let's go into here. Let's go to readme. Let's see. Let's delete that and go to this one. There we go. GS. We have. Oh, look at this. Look at this. We have our readme, but bam, we got to stash some changes. So I'm gonna jump in here and go. So for those that don't know, git stash. All it does is it takes whatever you were doing and puts it into like a special area. It's kind of like it's kind of like a commit. So if I look at git status, you'll notice there's nothing there. Git stash list. You'll notice that there is one right here. If we go git stash list, I believe it's dash p. You can see the change right here. Right? It's just like a special place to be able to put changes for a moment. I never use it long term. If you use it long term, you're crazy. Don't do that. That's absolutely nutty to do. Right? Absolute nutty to do. All right. Stash has a few options. Git stash, pop, list. The pop command will, by default, apply your most recent stash entry to your working directory and remove it from the stash list. It is effectively undoes the stash command. It gets you back to where you were. This is called a stack, and that's important, okay? Pop your stash change back out. You should see it working. Git stash pop. So it's a stack, and that's really, really important to know, because if you put
I wasn't listening at all.
area, it's kind of like, there we go, stash list. Okay, doesn't bother me. All right, assignment. While on main, update readme.md.
Ash. Git stash. Git stash. Once there is stash, make sure they are saved by listing your git stash. Git stash list. Okay. The pop command the pop command will by default apply the most recent stash entry to your working directory and remove it from the git stash. Definitely undoes the assignment.
In the root of megacourt repo to do this one. Bam, bam. Just after updating readme that the CEO approached you, stash the changes. Once you're stashed, make sure that they are safe in your list. Let's see, that they are safe by listing. Now it's okay to be able to see a single stash list. Okay, all right. Let's go into here. Let's go to readme. Let's see. Let's delete that and go to this one. There we go. GS. We have. Oh, look at this. Look at this. We have our readme, but bam, we got to stash some changes. So I'm gonna jump in here and go. So for those that don't know, git stash. All it does is it takes whatever you were doing and puts it into like a special area. It's kind of like it's kind of like a commit. So if I look at git status, you'll notice there's nothing there. Git stash list. You'll notice that there is one right here. If we go git stash list, I believe it's -p, you can see the change right here. Right? It's just like a special place to be able to put changes for a moment. I never use it long term. If you use it long term, you're crazy. Don't do that. That's absolutely nutty to do. Right? Absolute nutty to do. All right. Stash has a few options. Git stash, pop, list. The pop command will, by default, apply your most recent stash entry to your working directory and remove it from the stash list. It is effectively undoes the stash command. It gets you back to where you were. This is called a stack, and that's important. Okay? Pop your stash change back out. You should see it working. Git stash pop. So it's a stack, and that's really, really important to know, because if you push two things on top of your stash, you will have your latest one on top. The stash command stores your changes in a stack, Philo data structure. Also, I wouldn't say Philo, okay? I'm last in, first out. I'm more of a LIFO kind of person, Lane. Again, your copy editing hurts my feelings here. I'm a LIFO, not a Philo, I'm a LIFO, not a Philo. Yeah, for sure. That means that whenever you retrieve your changes from the stash, you always get the most recent changes. That's true. Bada bam. Philo is greater than LIFO. W Lane, false. All right, stash is a collection of changes that you have not committed. They might be raw working directory changes, or they might be staged changes. Both can be stashed. For example, make some changes to your working directory, stash those changes. Make some more changes without staging them. Stash all of that. When you do that, the stash entry will contain both staged and unstaged changes, and both your working directory and index will be reverted to the state of your last commit. It's a very convenient way to pause your work and come back later. Git stash is a very convenient feature of Git in which allows you to store your index and your work tree into a special area known as the stash, and then later on to be able to pop off those changes and reapply them to your work tree / index. But what is the stash? Well, it's a data structure that is a stack. So every single time you have a change to your index / work tree and you want to save it for later, when you call git stash, it actually creates something that's like a commit and adds it to this data structure, pushes it onto the stash stack. Any files that were not a part of your index / the work tree will simply be ignored. When you call git stash pop, it's actually going to take the last thing that you added to the stash and apply it to your current work tree / index. That means if you stash 3 changes, A, B, then C, if you pop something off, you'll be popping off C. Then the next time you pop off, it will be B. Then the final time you pop off, it will be A. If you're unfamiliar with a stack, it's actually pretty simple. Think of a stack of plates. If I add a plate, then add a plate, then add a plate. If I wish to remove a plate, I would never try to grab from the bottom. I would just grab one from the top, then the next one, then the next one. Whatever order you put in is the reverse order of what you take out. In other words, it's a last in, first out data structure. You can inspect your git stash by simply executing git stash list, which will show you in the order in which you pop out your stashes. Often I use the stash in a very one-dimensional way. I have some changes that I need to pull in from main, so I'm going to stash my current changes, pull them in, pop off my current changes, and continue on my work. I never use the stash as like a long-term storage place, just because my code changes so fast that it often gets out of date super quick. What is not staged? Unchanged, unstaged changes to the to the tracked working directory, staged changes, committed changes. You can't stage a commit, okay? You can't triple stamp a double stamp. If you push 3 sets of changes into the stack, let's call the first one A, the next B, the last one C. What happens when you run git stash pop? The changes from C are applied to your working directory, but the stash entry is not removed. The changes from C, I remember clicking this last time, it got me. The changes from C are applied to your working directory and the stash entry is removed. Let's go. Multiple stashes. And you can stash changes with a message. I rarely use stash. In fact, I never use stash messages that I can remember. I've used it like once or twice. The big reason why I don't do that is whenever you're doing this means that you actually want to come back much later, which to me just says this needs to be a branch in which you keep somewhere, and then you can edit the commit if you want to. You can rebase the commit. For me, stashing is a very, very like temporal operation. Assignment. Restash the changes to README with the message good marketing. Update the README file again with the following contents. Right? Git stash, message, good marketing. Boom. Right? And so we're going to go back here, and I'm going to go delete, and I'm going to have this one. There we go. Now, let's see. Stash those changes with bad marketing. Git stash bad marketing. There we go. And now we should do a stash list. Git stash list. You can see these 2 different ones right here. So that means if you add a P in here, you can see the difference. Unite marketing, sales, and service in a single app. Try Megacorp Starter Suite today. There's nothing to install. No credit card required. The only thing standing between you and more customers are your terrible salespeople. Get started today. It's pretty good. That's a pretty good one. Feels good. Feels good about it. All right, so there we go. All right. Unrelated commit. Now that you've safely stashed your current work away, let's tackle the CEO's urgent matter. Megacorp's APUX script or shell script truly is a feat of engineering. It behaves exactly as the shell, born shell language. But with the word, but if the word shell or sh is ever mentioned in the standard out, it will replace it with APUX. It's a feature that customers love, but it's not working. Let's see, test by running scan with the APUX language for shell. There we go. We're gonna grab this one. There we go. So you can see it right here. It's all right there. Okay, the grep command, let's see, the grep command should filter out the output to the lines that contain sh. You should see a couple lines, which means APUX sh isn't doing its job. The culprit is this line. Yeah. It should be replaced with sh, not bash. All right, we're going to update the script. Right? All right, let's update the script. Man, customers love just the craziest things, huh? Scripts, APUX, There we go. Wait a second. There it is. We got the apex. Okay, you're right. Git status, git add this, git commit L. The L stands for lovely reading, ThePrimeagen. There we go. All right, now that we got that, apply without removing from the stash. So you can actually do that. I'm not really sure the purpose of this, but it does exist. You can apply without, or you can remove from stash without applying. This makes more sense. Lane W prime L. Yeah, I know it happened. Reference a specific stash, so you can actually do it in one of these locations with the @ sign. So that means we're gonna have to do the one run git stash list, sees the stashes you have, apply the changes from good marketing stash index without removing it from the stash list. So we just have to do a little apply, do one of these bad boys, git stash list, paste that in there. There we go. Git add your changes to the index, drop good marketing stash, pop the only remaining one, bad marketing. You should notice that you have a conflict, resolve it by keeping the changes from good marketing stash, commit the changes M. All right, let's do that. Git stash drop the stash at 1. There we go. Git stash, or git add this, git stash pop. Wait. Oh, whoopsies. Hold on, what happened? Git status? Did I miss what happened here? Vim readme. There we go. I missed the message that said it did the wrong thing. So there we go. I'm going to remove the bad marketing one. Call it good. I missed the conflict message. How did I miss that? Oh, it's right there. It was right there the whole time. I just missed it. Again, it's that reading thing. You know what I mean? Okay, it's that reading thing that really gets me. Okay.
Okay.
All right, revert. When reset is a sledgehammer, revert is a scalpel. Revert is effectively an anti-commit. It does not remove the commit like reset, but instead creates a new commit that does the exact opposite of the commit being reverted. It undoes the change, but keeps the full history of the change and its undoing. So it's kind of like the Spider-Man thing. You know what I mean? Grug reading for a living, but Grug no read. Yeah, I know. It's sometimes you feel, right? All right. To revert a commit, you need to know what commit the commit hash of the commit you want to revert. You can do it with git log, all right? And once you have it, you do a little git revert hash with the commit hash. Assignment. In your great haste and pursuit of greatness at Megacorp, you forgot to write a white paper and get approval from the L69 distinguished staff architect for your marketing documentation change. The L69 has required you to revert the change. Ensure you're on main, revert commit M. It should prompt you to write a commit message. And we're going to call it N. Let's do it. All right. So we're like this. Git log, one line. So what do we need? We need this guy right here. Bam. Git revert, that one. N, save. Git log, 1 line. You can see right here. Here, looks like this. Git log, 1 line dash P2. So look at this. You can see that it's literally the inversion of it. The starter repo for the Git Course 2. That one removed it, this one added it back. This one added this one removed it. This one added that one removed it. So it's like an inversion. So that's what a revert does. It literally does like an antimatter commit to your history. And then it turns it into a commit, so you actually have it as a part of your graph. Oh, shoot, that's not right. Right, that's not right. That's not right. Did I mess that up? I must have messed that up. Yeah, see, it says git revert M. Okay, that's my bad. Git commit, amend. All right. There we go. That was my fault. That was my fault. Still doesn't read. I literally cannot read. The git diff command shows you the difference between stuff, differences between commits, the working tree, etc. I frequently use it to look at changes between the current state of my code and the last commit. I use it to look at. I primarily use it to look at not at that. Yes, actually that's exactly right. My current state. Sorry, that read funny. What my current changes are. I rarely use it for staged stuff. If you want to do stage, you have to do dash dash staged. Show the changes between the working tree and the last commit. You can do that. You can do difference between branches. You can do difference between 2 hashes. I've tried to do this for bigger ones and bigger projects. Once you get to a certain size, it's like impossible. Diff the changes between N and M commits. Remember, N is the reversion of changes and paste the full output in here. Git diff head tilde1. I believe is all I need to do. I think. I can't remember. Submit. Boom. Yeah. There we go. Bro, do you even diff? I diff. Okay. Just copy paste into Notepad++ with the differences extension. Wait, what? Why would you do that? Revert versus reset. Reset soft undoes the commit but keeps the stage changes. Undoes the commit and discards the changes. Revert creates a new commit and undoes the previous commit. There you go. When to reset, if you're working on your own branch and you're just undoing something you've already committed, say you're cleaning everything up so you can open a pull request, then git reset is probably what you want. However, if you want to undo change that's already on the shared branch, especially if it's an older change, then git revert is the safer option. It won't rewrite any history and therefore you won't step on your coworker's toes. Don't look at that. Don't look at it. When do you use revert versus reset? Well, they're actually quite different operations, so you just need to understand them fundamentally and it'll become obvious when you use one versus the other. Whenever I use reset, it's because I want to be able to take a commit, undo that commit, make some edits, and recommit. And in the case of git reset hard, I actually just want to throw away that commit. This means I'm working on my own branch, not on a branch everybody else uses. I'm able to edit the history and get it into the way I would like it to be. Whereas a revert is more for the public branch. What this means is that you have a problematic commit, and you need to be able to remove that commit, but you could never do that to a public branch because it's going to break everybody. So instead, you make like an antimatter commit, right? This commit contains changes A, this one reverts changes A. And this also has the added benefit that if you want to go back in time, you can go back to A and actually fix the bug, and then reintroduce A along with its bug fix. Now, I find that I revert when I'm on a larger team because often you're in this position where somebody needs this change to go out, such that a new customer feature or a new A/B test that's high priority has to get out, but your changes have broken the build and were not discovered until we released into production. So we need them out right away. There is no waiting. There is no waiting to fix forward. So therefore, you simply revert your commit, fix the change, create a new commit with the fixed code and all the changes back in, and then next release your code can go out. And hopefully it's not broken. But if you find yourself reverting a lot, it's likely because you have a pretty unhealthy process. Your CI/CD is not up to snuff, your tests aren't quite there, your automation is no good. Production is the ultimate place to test, but it should not be the only place you test. Which creates a new commit? Revert. Let's go. Which rewrites history? Reset. All right, there we go. Cherry pick. Everyone loves cherry pick. This comes a time in every developer's life when you want to yoink a commit from a branch, but you don't want to merge or rebase because you don't want all the commits. Git cherry pick is another one of these very useful Git operations, but you infrequently need to use it. Cherry pick is when you want one change from a branch, but you don't want the entire history of the branch. You only just want, say, a singular commit or 2 commits. Where cherry pick is obviously useful is when you have a branch that's called release, and then you have your main development line. Every now and then, release gets cut and that branch gets updated. Now let's pretend you've been going and there's hundreds of commit in main, but we discover a bug in production. Well, we could fix the bug in main and then just transfer over that one and singular commit to release and then reproductize release, thus fixing the bug, but we don't contain all of the changes from main because those changes are largely untested, or maybe they contain half-baked features that are not ready to go out quite yet. So this is where cherry pick works. So switch to a new branch off of main called add partners, update the partners organization to be this one, commit the changes with O, update the same file again with P. All right, let's do that. All right, git branch. Let's see what branches I have. All right, cool. Git check out dash B. Still not doing it. Still not using it. Lane was just like, we should use switch. And I was like, dude, I'm all about that C. About that C. Git checkout. I just am. I can't help it. I can't help it. I just have to. All right, there we go. We won't sub if you don't use switch. Nope, then don't sub. I'll ban you. How about that one? How about that one? Tough guy. Git commit dash O. Okay, the setup. We're gonna do the setup. My face. Yeah. Oh, wait, yes. So now we gotta do P. All right. Vim partners. Dap paste. Let's go. Here. Git status. Git add. Git commit dash P. On the electric fence, huh? Little callback to Ren and Stimpy. I think I spelled fence wrong. Whatever. That's close enough. You know what? We're close enough. That's a little Ren and Stimpy callback. Okay. It's been a long time since I've watched some Ren and Stimpy. Okay, close enough. All right. What theme of VS Code is this? You know exactly what theme it is. Can read nor write. All right, how to cherry pick. First, you need to clean working tree. No uncommitted changes. Identify the commits you want to cherry pick. Typically with git log is a good one. Run git cherry pick commit hash or commitish would be better. Git log to grab the first of the 2 commits we just made. Oh, that's the one we want. Git log. There we go. I'm gonna grab this bad boy, my O face. Then we're gonna go in here, cherry pick O onto main. Ensure that let's see, it worked by checking the partners one. Delete add partners. Boom. Git cherry pick that. Oh, I just did it onto my own thing. Git status. Git. I didn't even change branches. Abort. Boom. Oh my goodness, I have a revert in progress. Oh my goodness. Wait, how do I have a revert in progress? How did I do that? Okay. when did I do this? All right, hon. Git log. All right, so I have the revert right here. All right, so that's already been committed. So that's not a problem. Git branch. We have our 2 branches. I'm on main. Let's see, no cherry pit. Oh, I have a board. Am I actually calling a board? Oh, dude, I'm so stupid. I didn't even see that I was doing a board. Okay, I am really not reading. It's been a long day. I don't know if you guys know this, but I've been streaming for track hours, 9 hours. Okay, it's been a long day. All right, there we go. So I moved over this right here, so I can go get log dash p, so we can see right here, close ML, one of our favorite startups. Right? Can't even read the timer. Okay, shut up. Shut up. It's been so long. I'm not good at doing this much stuff at a time. All right, we need to delete the add partners. Get branch, delete add partners. There we go. The man's losing. I've lost it. I fully lost it. I've lost it. Let's go first try.
Damn, I'm 23 years. I should be like quick.
Oh yeah, we're up to bisect. You like bisect? You guys want to bisect? All right, so bisect is fantastic. Let's do this, okay? Let's do this. Git bisect is yet another Git command that does sound quite intimidating to the uninitiated, but once you learn how it works, it is actually quite simple. Git bisect allows you to find a commit in which introduced a bug really fast, and it does this by using a technique called binary search. Let's just pretend that we have a branch that has many commits on it. Our latest commit contains a bug, and 100 commits ago does not contain the bug. How are you to find when the bug was introduced? Well, you could go step by step through it until you find where the bug's at, but that would be tedious. If it takes a couple minutes per try, it could take all afternoon or multiple days. But since commits are ordered by time in which they are merged, we can actually pretend they're an ordered array and do a binary search across it. So this is how Git bisect works. Let's pretend that we have a known state that is bad and a known state that is good, and we have a bunch of commits in between all of this. We'll call it X amounts of commits. If we test the middle commit, and let's pretend we found this middle commit is good, we know that all of this is good. In other words, we've cut our space in half. We have X divided by 2 minus 1 left commits to check. And if we repeat the process, we can continue on finding smaller and smaller regions to go check for our commits. If we find one of these are actually bad, then we know that all of this direction is bad. And we repeat this process until we're able to find a singular commit that is the commit in which the bug was introduced. If X was 1,000, it would approximately take us 10 checks to find the bug. And using Git bisect is really simple. You set the good commit, you set the bad commit, you say start, and it will start doing that exact same process of cutting the known space in half, asking you if this commit is good or bad. If you answer good, then it knows all the commits earlier are good. If you answer bad, it knows all the commits that are ahead are bad. This can save you days of searching. So we know how to fix problems in our code. We can either revert the commit with the bug. This is more common on large teams, or fail forward by just writing a new commit that fixes the bug. This is more common on small teams. Well, if you have the time, this is the ideal in my head, is to be able to always fail forward, right? That is my favorite. But there's another question. How do we find where the bug was introduced? That's where Git bisect command comes in. Instead of manually checking all the commits, that's big O, right? Big O N, I mean. Git bisect allows us to do a binary search, which is log n. So that means after like what, 10,000, it's only 14 checks. It's the way to go. So if you don't know how to do bisect, bisect is fantastic if you're working on a slightly old code base that has thousands or hundreds of commits, right? All right, let's see, bisect isn't just for bugs. You can do anything. So the nice part about this is anytime you have a change you're looking for and you have a script that you can check, then bisect can be used to find where that, say, improvement and performance improvement was introduced, performance regression was introduced, anything. So bisect is fantastic. The purpose of bisect is to split the repositories into 2 separate repositories, split the commit into 2, find a commit that introduced a bug or change. Say it that way. A commit to find a change that was introduced. There are 7 effective steps to bisecting. That's it. There's really a quick 7. Now, you know me from reading, right? Am I right? You know my skills at reading, so we're about to go deep on this one, okay? Yeah. All right, start the bisect with git bisect start. Select a good commit. Select a bad commit. Git will check the commits between them and find it. Execute git bisect good or bad to say the current commit is good or bad. Loop back to step 4. Exit with this one. Git bisect reset or reset. There you go. Assignment. Your boss just chewed you out because the scan sh script should never have been added to the repo. Not only does she want the contents of the script erased, but she wants to know when the script was added, and for you to fix it with git revert, so the history of your royal screw-up is preserved. Considering you can't remember when you wrote the script, you decided to use git bisect. Start bisect. You know the head commit is bad, so mark it as bad. You know the first commit A is good, so mark it as A. If the script content is present, not just a to-do comment, mark the script as bad. Otherwise, mark it as good. Repeat step 4 until git bisect completes. It should give you the hash of the commit. All right, so this should be pretty easy.
I
Do you
think
understand?
like, okay, I think I have
Right?
like,
Boss should have been a code review. Yeah, no, boss, yeah.
for like this whole thing. I learned how to git branch, git. I think the main thing is like branching, merging conflict, and go on. Rebase as well. Rebase is really useful. So from now on, when obviously I'm a solo developer, so it wouldn't be like that important. But if I want to test some new feature, I could just do the branch, and then it's like really easy and it's really useful. Yeah. That's it for today, and I have today and two thing I did today and I did yesterday, and yeah. So, see you.